Alright guys, for this first one we have Paul, our good old friend Paulie, has a bar graph for the total number of goals scored in each game of a soccer tournament in 2024. Good old friend Paulie is a football fan, so in the bar graph shown below, the frequency of 4 goals in the game is unreadable, which is this big gecko splatter that is on the bar graph. Alright, so we have this bar graph, and then on the side we have this frequency table. Now the frequency table, what it sort of tries to do, or better said, the bar graph, what it tries to do is to portray what the frequency table says. So for example, this 0 with 3 is this 0 with 3 here. This 1 with 11 is this 1 with this 11 here. And so the frequency table is showing a lot about the bar graph has. Okay, that's like the first idea we have to sort of try to establish. And so for part A, it says write down the value of K. And so if we take a closer look, K is with respects to 3. So we look at 3 and we see how much frequency it had. So it had at least 4, but this thing is between 4 and 6. Well, what's between 4 and 6? 5. So we can write down that K equals 5. And some of you might be worried about something like showing your process, showing your method, but this is worth 1 point. And so when it's worth 1 point, it's usually just like, can you read the bar graph? Okay, so K equals 5. This is all we have to do in this case. And the answer key expresses it as so. So no method point, is just reading the bar graph. K equals 5. Bada bing, bada boom. Our good old friend Paulie knows that the mean number of goals, so this is an interesting, topic, per game scored during the tournament was 2.2. And through this, part BI is telling us to write down an equation for the mean in terms of P. So the mean in terms of P, this right here in terms of P is massive. So there's a lot of stuff going around here. The first thing we need to establish is what the heck does mean even mean? And so mean, we will associate it to something like average. And the mean or the average is actually and your good old friend, the formula booklet. Guys, the day of the test, you're walking in with a couple of things. A pen or a pencil, a graphing calculator, 2 years of experience of this thing called IB, 2 hours of sleep, and the formula booklet. Así que the formula booklet is something you have to learn. It's going to help you. It's going to save you. It's not just about having the formulas, it's about understanding them as well. And so the mean, which is the same mean that they mentioned here, is in your formula booklet. And as you can see here, the mean, it says it's X with a little bar on top, which is also relevant when we want to find it in the calculator. Knowing that it's an X with a bar on top can be useful. And it says that the mean will be, this thing divided by n. Okay, and what the heck is this thing up here? It's going to be basically your data. And the reason it might have an F times an X inside of it is because if you have a frequency list, you would do, each of your data times the respective frequency. In this case, there isn't frequency. So it's just going to be your data added together. That's why there's this fancy symbol, because this is a fancy symbol for like add everything in this group. Okay, so your data added together divided by your total. And your total is going to be n. So basically, intuitively, what I'm trying to tell you is that you can forget about this for a second. And you can have the intuition that your mean is your data added together divided by your total. So data added together divided by total. Okay, so my data added together is going to be this 0 3 times. So we can do 0 times 3 plus 1 times 11 plus 2 times 7 plus 3 times k, but we know that k is 5, plus 4 times p, and plus 5 times 1. So that would be the portion of your data added together, the thing up top, and on the bottom is going to be your total. So your total is going to be, actually, what is my total? Do we have our total? Blah, 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 blah. I think we don't have our total. That's interesting. And so the total, well, we don't have like the total as a number, but the total would have to be the amount of frequency that we have. All right, so the amount of frequency that we have would have to be our total. And when I say total here, I guess I should specify it's your total amount of data points. And so data points is going to be like each time you took down, like you wrote down something. So for example, you wrote down 0 3 times. That means you have 3 data points, ¿cierto? But your data, when I say your data, right, it's going to be 0 3 times, ¿cierto? And so careful with that. Okay, so data points would be your frequency right here. So your data points would have to be 3 plus 11 plus 7 plus k, which we know is 5, plus p plus 1. And so there we expressed our mean, but part BI is saying write down an equation for the mean in terms of p. And so notice, whenever it says something like in terms of p, it means you have to end up with this equals something something p. So mean equals a bunch of stuff, probably like a times p. Okay, so in this case, we have that our mean actually, so all of this equals your mean. So mean equals this whole thing. So that means we have mean in terms of p, because mean equals a bunch of numbers and stuff, and p is in between it. So that is what they mean by mean in terms of p. Mean is going to be alone. So mean equals all of this stuff, and then p is going to be plugged in somewhere. Unfortunately, here Polly tells us from somewhere that although they spelled gecko all over the bar graph, we have mean equals 2.2. And so here we can write down 2.2 equals this thing here. Yeah, perfect. So that would be our equation for the mean in terms of p. And as we can see here, that is exactly what occurred. So 2.2 equals this entire massive thing. For us, we left it a little more intuitive by doing parentheses here. Okay, it's not that it's necessary, but I think in terms of thinking about it, it's a lot simpler. So frequency times amount, etc. And we could have simplified it, but whatever, I'd rather stick to the intuitive version. So the intuitive version looks like this. And from here, we can try to attempt to solve or determine the value of p, which is part b double I. So this would be part bi. Part b double I is like actually solving this, ¿cierto? So for actually solving this, I can leave it as 2.2 equals, and then we have to go solving. So this guy here is just going to be 0, because 0 times 3 is just 0. This is going to be 11. This is 2 times 7, which is going to be 14. This 3 times 5 is going to be 15. This 4 times p ends up as 4p. And this 5 times 1 ends up as 5. On the bottom, we see that we have 3 plus 11 plus 7 plus 5 plus 1, and then the p next to it. So all of that being said, we can add this stuff in red. So the stuff in red is 11 plus 14 plus 15, the 4p not yet, and then the plus 5. So that means up top you end up with 45 plus 4p. And on the bottom you have 3 plus 11. So this 3, this 11, this 7, this 5, this 1, not counting the p, 27. So 27 plus p. So this is the first sort of step, which is actually, or should be the same as here. And as far as I can tell, it is. All good over there. As you get from here, we can attempt to determine the value of p. Now, solving p from here is not too friendly because p is on the top and on the bottom. And so basically, whenever you're sort of stuck on a math exercise, I highly suggest that you ask yourself, what is annoying me? And it's what is annoying me right now. Not that Riot can't balance their League of Legends champions. It's what is annoying you right now. So what's annoying you right now is that you have a fraction. And what is one way to try to get rid of fractions? Here is a magic trick. Multiply by the thing on the denominator. And so if you want to get rid of the fractions, well, this is the part that's annoying you truly. And so what you can do is multiply everything by 27 plus p. So that means if you do it on one side, golden rule in algebra or whatever, you do it on the other side as well. So both sides are being multiplied by this parentheses. So that means that when you do that, this goes away with this. And so on the left, you end up with 2.2 times 27 plus p. And on the right side, because you got rid of the denominator, you end up with 45 plus 4p. Now I know that this doesn't look exactly friendly, but there isn't a fraction anymore, which was what we were trying to do. So from here, you can do the 2.2 times that 27, and you can also do the 2.2 as just times p, so it ends up as 2.2. So that means you end up as 59.4 plus p equals 45 plus 4p, and from here there's a million ways to solve it. I like the idea of doing minus p, so you end up with 59.4 plus p equals, sorry, I'm trolling. Let me go again. You end up with 59.4 equals 45 plus 3p. So then you do minus 45 to both sides. You end up with whatever that is. 14.4 equals 3p. As you can divide by 3 to both sides, p equals something. And that something is going to be our good old friend, number 4.8. Nice and exciting. P equals, wait a second, 4.8. How can I have a frequency that's 4.8? All right, I'm leaving this in the video because it can happen to anyone, but it's interesting how I reached the answer of 4.8. And the frequencies, you can't have half a goal or a third of a goal. So clearly I messed up somewhere. So let's take a moment to go over where I might have messed up. I know that from here I'm fine. So let's take a second from here to understand what could have gone wrong. 2.2 times this gives you, perfect. Yeah. All right. Again, leaving this in the video because it can happen to anyone. I saw this answer and I questioned it immediately because you can't have half a goal. Así que, going back here, I spotted my mistake a little bit earlier, and it's right around here. And so here, when we distribute it by the 2.2, the 59.4 comes out, but over here, I should have come out as well with plus 2.2p. Así que small, but extremely relevant detail. Now we can try to solve. Now we do minus 2.2p to both sides. So that means we end up with 59.4 equaling 45 plus 1.8p. And from here we can do minus 45. So that means we end up with, how much was it? It was 14.4, I think. Let me take a second to think. Más 4.4, that makes sense. 14.4 equals 1.8p. And so now we divide by 1.8. And now p should make a little bit more sense. If I do some quick maths, I think it should be 8. P equals 8, which is the same 8 we see over there. As I get bada bim bada boom, I appreciate the minute to show critical thinking skills where p had to be like a whole number. So good thing we noticed that. Good thing we caught that. P equals 8. I'm going to rewrite it up here just so that we remember it. So this is 5, and this is 8, and the total, which might be relevant later, the total is 3 plus 11 plus 7 plus 5 plus 8 plus 1 gave us that 35. So 3 plus 11 plus 7 plus 5 plus 8 plus 1 gives you the 30. 5 is our total. Yeah, perfect. That would be for part A and B. Now we can move on to part C. Now part C gets a little bit more exciting because they tell us a bunch of stuff. First, they start by telling us that the data for the number of goals per game in a 2025 soccer tournament are showing in the following box and whisker diagram. Ahora, ojo, 2025, and up here it was 2024. So it's a different year. And they tell us that after comparing the box and whisker diagram for the 2025 tournament with the frequency table from the 2024, so they're comparing 2025 with 2024. Good old friend Polly, who's a big mathematician says that the distribution of goals is consistent between the two tournaments. And for part C, we need to state two ways in which we support our good old friend Polly, because you got to support your friends. Comparing any of the two, so they actually tell us how to compare. We can compare with the range, the symmetry, the median, or the interquartile range. Any of that works. Alright, let's be honest. At this point, most of us are probably saying, what the heck is happening? How did you interpret this again? Box and whisker? What is this, like an anime? Range, symmetry, median, what are all these words? What is happening? Let's go piece by piece. First of all, how the heck do you interpret a box and whisker diagram? Why is it useful? The reason that the box and whisker diagram is useful is because visually it's very appealing for understanding where your data is concentrated. Así que the box and whisker, following its form, the way you understand it is that this guy here, like the thing that ends like this, okay, is going to, will always be what we call the minimum. So that means on the other end, it's going to be your maximum. Then I have three things. I have Q1, I have Q2, and I have Q3. Now from here, most of us might be saying, what the heck is Q1, Q2, Q3? Q1 is going to be what we call like the first quarter. And so if it's your first quarter, well, quarter in quarts, it's 1/4. And 1/4 is how much? 1/4 is 0.25. And so you can also think about it as, okay, one quartile is of the first fourth of my data, because this isn't ascending order. See, so it's going to be the first fourth of my data, and 1 divided by 4 is 0.25. So you can think about it as quarter 1 being what we call the 25th percentile. And so organizing your data from minimum to maximum, quarter 1 is the 25th percentile. So if you organize your data from, from the lowest to the highest, I'm going to see, okay, who's on spot 25%? ¿Cierto? Who's on the 25th percentile? That would be Q1. Q2, of course, is going to be 2 quarters. So it's 2 divided by 4. So it's 0.5. Yeah, so it's 50th percentile, which is, surprise, right at the middle. So Q2, and this is massive, Q2, you can also think about it as the median, because it's right on the middle. And last but not least, quarter 3, logically, is going to be the 75th percentile, because it's 3 quarters. And so you guys might be thinking, well, why is this useful anyways? Like, I get it, but how is that exciting at all? It's exciting because this is your lower 25%. This is the 25% between Q1 and Q2. This is the 25% between Q2 and Q3. And this is your upper 25%. And some of you might already be thinking, how the heck can you tell me that all of this is 25%, but also all of this is 25%? And that is when I tell you, that is the magic and the cool thing about the box and whisker diagram. Because the box and whisker diagram, besides having a weird anime name, it's also telling you the spread of your data. And as I said earlier, the key word, for me at least, is how concentrated your data is. And so in this case, with my wonderful handwriting concentrated, you can see that your first 25% of your data is extremely concentrated. It's all close to each other. But in the top 75% and onwards, so between Q3 and the max, your data is very spread out. So basically, you can say that a lot of games are concentrated between 0 and 1, 1 and 2, 2 and 4. And the ones that are 4 or more are super spread out. See? And so that's a little bit how you attempt to interpret the box and whisker diagram. But the relevant part for me is understanding where the Q1 lands, where the Q2 lands, where the Q3 lands. And so in order to even start to understand how to compare range, symmetry, median, and interquartile range, which I will get into what each of these mean in a second, it's important that you can identify the min, the Q1, the Q2, the Q3, the max in the box and whisker, but also here. So think about it this way. If you are able, this paper 2 doesn't give me space, so we're going to do it here. But think about it this way. If for 2024, you were able to establish the min, the Q1, the Q2, which we know is median, the Q3, and the maximum. And the same for 2025. So establish this for 2024, but also 2025. Then it would suddenly become much, much more easier to compare both sets of data. ¿Cierto? And so remember that the 2024 is our frequency table or bar graph. And also for 2025, we have the box and whisker. The anime name. I mean, I call it anime name because it sounds funny, but whatever, box and whisker. See? And so if we are able to understand what is the minimum in both, what is Q1 in both, what is Q2 in both, Q3 and max in both, then our task becomes much easier. And so actually the cool thing about AISL is that that is exactly what it's challenging you to do. It's challenging you to understand how the frequency table translates to a bar graph, how the frequency table translates to a box and whisker, but also how the box and whisker might translate to a frequency and so on and so forth. So the cool thing about AISL, I think at least, that it tries to teach you is understanding how to interpret these graphs, which is sometimes even more important than building it in the first place. Yeah, so the way to understand how minimum Q1, Q2, Q3, and Qmax show up in this frequency table is that first you press on stat, because this is a very statistical thing to do, and you press edit. And so when you press edit, from here you can plug in basically this table over there. Now, as you can see, in this case, we do have what we call a frequency list. And so that means that L1 is going to be the number of goals and L2 will be our frequency. You're going to see why in a second. So L1 we can write down 0, 1, 2, 3, 4, 5. And the frequency list we can put 3, which means that 3 times there were 0 goals. So 3 times there were 0 goals. And then 11 for the next one. So 11 times there was 1 goal, and so on and so forth. As equals 7, 5, 8, 1. I always suggest to take a second to make sure everything's aligned. I see it good. I see it good. So here you can press stat again because it's the very statistical thing to do. Go to calculate, and here you can do what we call 1 var stats. Why is it 1 var even though there's 2 lists? Because it's only one variable. It's only the number of goals. Frequency is not a variable. I mean, not exactly. So you get 1 var stats. You can put list as list 1, and your frequency list is list 2. So how the heck do you express list 2? Over here, there's a blue L2, so you press second and then 2, hit that L2, press calculate, bada bim, bada boom, there appear your 1 var stats. And so a lot of this, as you can tell up to now, is understanding a little bit concepts, but also understanding the capacity of your calculator. Así que 1 var stats is something that you end up using more than what you think. And so managing list 1, list 2, and understanding all of that stuff is essential. I don't expect you to memorize everything your calculator can do, but I do expect you to know the tools that are in there. You have to think about, or what I suggest for your study method, is that you have to imagine that you're building or adding tools to a toolkit, to a toolbox. And so a toolbox is going to end up with a bunch of stuff. Okay, so you end up with a hammer, with a bunch of nails, with a screwdriver. There's a bunch of stuff in there. And every time you open the toolbox, you probably don't know where it is, but you know that it's in the toolbox. And that's the whole point. So this is something you have to know, that it's in your toolbox. And so the day of the test, I would expect you to press stat and probably scroll a little bit, maybe press on the wrong buttons a bunch of times, but eventually you reach this screen and it rings a bell. You reach the part where it says var stats and you say, was it the 1, was it the 2? But then pressing one or the other, you realize, yeah, it's 1 var stats. Boom, 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 you reach this. See, so that's the procedure I'd suggest you to go for. The first thing I can mention is that this X with a bar is the same X with a bar that appears here. So for mean of data. So good to know that is a universal symbol for mean. The next one is actually the sum. Then below it sets sum squared of your X values. This is a thing we call variance. Then below it's standard deviation. Variance, you're never going to use. Standard deviation sometimes. Actually, AISL level, I think you don't. But anyways, good to know. So variance, standard deviation, n is 35, which is your total, the amount of data points you have. And this is the interesting part for me, at least. From here, now we have the minimum, the Q1, the Q2, the Q3, and the max. And suddenly it becomes so much more easier to compare. So we're going to go ahead and write that here. We have that the minimum is 0, that the Q1 is 1, that the Q2, which is the medium, is 2, that the Q3 is 4, and that the maximum is 5. And interpreting from the box and whisker, we have that, again, the minimum is 0, the Q1 is right on 1, the Q2, which is the medium, is right on 2, and Q3 is on 4, the maximum is 9. So 0, 1, 2, 4, 9, 0, 1, 2, 3, 0, 1, 2, 4, 9, 0, 1, 2, 4, 9. Perfect. And so now we can easily compare 2024 with 2025, and the 4 ways they told us we can do it is through range, symmetry, median, or interquartile range. So the first thing we're going to embark upon is range. Okay, we're actually going to do both of the ranges first. So I'm going to explain this guy and this guy. And this is the kind of thing you just sort of have to know. Okay, when you talk about range in statistics, the intuition I need you to have is that it's going to be your max minus your min, which actually sort of makes sense. It's like, what is the range? How far can you go? ¿Cierto? So literally Spear has a maximum range of the whole map. And so the max would be the whole map, and the minimum is just landing a target that's right in front of her. And so max minus min, well, you end up with the whole map. Point is, range is going to be max minus minimum. And so interquartile range, if you can see here, it says interquartile. So it's talking about quartiles. Interquartile, it's actually in your formula booklet as well. There it is, Q3 minus Q1. So notice how this buzzword, I have it in my brain as something that it's in my formula booklet. So the day of tomorrow, the minute you read interquartile range or you read IQR, again, not by memory, but you know it's somewhere in here, you know it's somewhere in your toolkit, you're going to look for it and you find it, Q3 minus Q1 is your interquartile range. Why do we use this? Because the interquartile range basically is the middle of your data. And so it helps you understand how the majority, or the, I don't know if the most relevant, but yeah, in most cases, the most relevant part of your data, the middle portion of your data, how it behaves. And so that would be for range and interquartile range. For the median, it's literally just going to be Q2. And then for symmetry, that's a little bit harder to sort of try to explain. But for symmetry, it would be like if it has what we call a right skew or a left skew. And so in this case, I'm pretty sure this is a right skew because you have a bunch of data points that go very far to the right. See, and so that would be what we mean by symmetry, okay? And so that's a little bit harder to explain, so I'd rather stick to range, median, and interquartile range. As you get up here, we can say that, for example, the range of 2024 was 5 minus 0, 5. And for the box and whisker was 9 minus 0, 9. For the interquartile range, we can say that for 2024, it's Q3 minus Q1, which is 3. And then for 2025 was Q3 minus Q1, which is again 3. And for the median, we can say that it's simply Q2. So Q2 is 2, and over here it's 2 as well. And so 2 ways for me that I would say that our good old friend Polly is on the right track is saying that IQR and median is the same between both years. I know we can answer through symmetry, but for me, the friendliest approach would definitely be simply median and IQR. And so if we look at the answer key, it says clearly one part of part C, which is worth 3 points, is identifying Q1, the median, Q4, IQR from 2024. So notice a big portion that the IB is trying to get you to do is to convert this frequency table into this for understanding these guys here. I say, yeah, that is something that the IB pushes for, which I think is great. And then it says any of these 2 statements can work. The both medians is 2. Here it is for comparing the IQR. And then here is the distribution of skew to the right. So yeah, skew to the right visually here occurs because although my data is concentrated on the left, the bigger spread of my points is on the right. So there's a big spread on the right. And over here, we can say something similar. You can say that most of it is on the left, but there's a bigger spread on the right. It gets farther out on 5 and 3 and 4, ¿cierto? So that would be a little bit how to interpret part C. So part C was a little bit longer, but we did go over all the tools we need to do. We learned a little bit about the anime graph. Así que worth it. Now we have that our good old friend Paulie plans to watch all the games from the 2024 tournament in random order because Paulie has a lot of time. And he's a little bit of a nerd, which I share. So he will watch each game once. And for the first game he watches, he defines event F as scoring either 0 goals or exactly 1 goal. And here is a big brain moment for part D. Write down the events from the table that are equivalent to F with an apostrophe. There may be more than one correct event. And so before looking at any of this, don't look at it yet or else you're going to get stressed. Let's first understand what is happening with F apostrophe. And so F apostrophe, believe it or not, is actually also in what we call your formula booklet. Apostrophe is what we call a complementary event. Now, what the heck is happening here? As you can see, in the world of probability, it's saying that the probability of A plus what we call its complement equals 1. And so you can think about it this way. Here you have the probability of A, and here you have the probability of not A. And so basically that's the power of this apostrophe. It's telling you not this thing, not A. And so in the world of probability, the probability of A plus not A has to equal 1. It has to equal 100%. You can think about it as like, I don't know, what's the probability to go to the bathroom? 30%. What's the probability that I don't go to the bathroom? 70%. 30% plus 70%, 100%. What's the probability that I throw this game? 99%. What's the probability that I don't throw this game? 1%. 99 plus 1%, 100%. Okay, that's a little bit the idea of complementary events. So coming back to reality, here we have that F is scoring either 0 goals or exactly 1 goal. And so this part is a little bit hard to explain, but I think it's useful how you think about it. And so F, how do you think about it? You think about it as maybe like a set of cases. See? And so thinking about it as a set of cases, F can be either 0 or 1 goal. So it would be 0, 1. And so that means that complement F, so not F, is going to be within the world of, well, not 0 or 1, so it has to be more than that. So it's going to be 2, but also 3, 4, 5, and basically infinity. And so once we establish it like this, part D becomes a lot more friendly. And so F is either 0 or 1, and complement of F is 2 or more. Así que ojo, 2 or more. And so coming back down here, they're telling us that we need to write down which events from this table are equivalent to F complement, so this guy here in orange. There may be more than one correct event, so we gotta go one by one. And this first one is the weirdest one for me. It says event A is scoring exactly 2 goals in this game. Ahora, if I think about this in terms of like the grouping that we did earlier, it means that it says scoring exactly 2 goals. So it would be the group of scoring, well, simply 2. And so the interesting part here, or the super hard part to understand, is that event A is scoring exactly 2. So it's like these brackets with 2. F complement includes the 2, but also the 3, the 4, the 5. And so unfortunately, this here does not equal F complement. This here is inside F complement, yes, but it isn't equivalent. Ojo, it isn't equivalent to F complement. So in this case, event A, we would say no. It is not part of F complement because F complement includes 2, 3, 4, 5 onto infinity. So that is a little bit of a brain teaser, but it's important to have clear why we reached the conclusion that we reached. So event A, we will be discarding it. Event B says scoring more than one goal this game. And so more than one, we would say, well, it can't be 0 because you score at least 1. It can't be 1 because it says more than 1. And so the brackets in this case would be 2, also 3, also 4, also 5, and so on. And so in this case, we do have a complement that works. I mean, we do have a group of numbers that works for F complement. Part C says scoring at least 2 goals in this game. So not 0, not 1, at least 2. And 3 is also at least 2. 4 is also at least 2. 5 is as well, on to infinity. So event C also applies. Event D is a little bit more weird because it says scoring either 0 or exactly 1 in all games except this game. And that's a little bit more weird because here when it says except this game, it means that in all of them it's going to be F, but in this one, no. And so because it says the thing of in all games or the except this game, it steers away from what we define as F. It steers away as what we define as F a complement. Okay, because F over here is talking about like just this one match or just this one observation. So F complement is also implied for just this one observation. And here when they put the words except this game or all this game, we immediately say nuh-uh. Originally, I'm not focused on other games, I'm focused on this one. Okay, I'm focused on the interpretation of one data point. So I don't care about the comparison to others. As you get part D, we can discard. Part E, we can also discard because it says any game, not what we're interested in. As you get part D, we would simply end up with our answer as B and C, and that is exactly what occurs here. Wonderful. Now we go on to part E. And so part E, our good old friend Polly is still extremely entertained with these soccer matches statistically. And so good old friend Polly gives us the math homework for some reason that if exactly 1 goal was scored in the first game that Polly watches, write down the probability that exactly 1 goal was scored in this second game he watches. Give your answer as a fraction. Now, the first thing we have to have clear is what set of data are we talking about? Because remember, we have 2. We have one for 2024 and one for 2025. And so over here, from this point onwards, we have that Polly watches the games from 2024. So that's a small detail we have to keep an eye on. As you get 2024 is what we're going for here. So this is the data we're talking about for 2024. Así que, for part D, if it says exactly 1 goal was scored in the first game he watches, and then the second game also has exactly 1 game, basically, here it says if on the first game 1 goal, and then it says 1 goal second game, give your answer as a fraction. That is what we have to express like in math terms, okay? And in the world of probability, there's a couple words that are extremely important. Whenever you find yourself thinking in terms of and, we will be multiplying. And whenever you think of yourself thinking in terms of or, we will be adding. Así que from that perspective, we can say that for part E, it's basically asking the probability of scoring exactly 1 goal first match and scoring exactly 1 goal second match. So for this first part that I will be expressing in, let's say, red, so 1 goal first match, well, 1 goal here, apparently there were 11 cases of 1 goal, and our total, as we said earlier, is 35. So the probability of scoring 1 goal, which were 11 cases out of 35, 11 out of 35. Así que scoring exactly 1 goal is going to be 11 divided by 35. Here we have the and, which is going to be multiplying, and scoring exactly 1 goal the second match. And this part is interesting because if 1 match already happened and now we're talking about the second match, well, I can't put 11 again because I already just saw 1 of those cases. And so because you already saw 1 of those cases, you actually express 10. And because you're looking at the second match, your total is not 35 anymore, it's one match less, it's going to be 34. And so actually, your probability is 11 divided by 35 times, because of the end, 10 divided by 34. So all of this in our good old friend, the calculator, we can express it like this. And that would be the probability of both of those things happening. But now that I look at this exercise a little more closely, it says, if one goal was scored in the first game he watches, write down the probability that exactly one goal was scored in the second game he watches. And so here there's actually an additional thing I missed a little bit, is that at the start it's saying if. And so basically we are taking this part for granted. So this is taken for granted. They're only asking about this probability over here. And so the cool thing about the word if is that although it's extremely hard to interpret in the world of probability, it's conditional. And so the cool thing about conditional is that you take this first thing for granted, you only focus on the second part. And so for this conditional sort of like probability, they're only interested in the probability of scoring exactly one, but only on the second match. As you get, your answer would be 10 divided by 34, which is the same 10 divided by 34 that we see here. The 5 divided by 17 is simply, correcting the answer or whatever, solving fractions. See? I think in this case, your answer would be 10 divided by 34. That would be, for our good old friend, part E. And then part F says, calculate the probability that 5 goals were scored in the first game that Paul watches, and that 0 goals were scored in the second game he watches. So now we are more in the paradigm that I was trying to express earlier. The probability of 5 goals in the first match. Well, here, what is the probability of 5 goals? Here we have the 5, which happens only once out of 35. So you can immediately express 1 divided by 35. And because of this and that they put in bold, and for multiplying, so 1 divided by 35 times the probability that 0 goals were scored in the second game he watches. Well, 3 matches had 0 goals, and we already went through the first one, so it would be 3 divided by the new total, which is 34, because we're talking about the second match. Así que aquí, it would be 1 divided by 35 times 3, which is the probability of 0 goals, divided by 34, because we are already on the second match. And so now the logic of the and is applying. So here end up with 1 divided by 35 times 3 divided by 34. That gives you the 0,002, which looks just about right to me. Ladies and gentlemen, that is how you would solve for part F. Number 1 is actually not too friendly, I would say, but the cool thing that we went over today is understanding a little bit better what complement means, how to pass from the box and whisker or from the frequency table to this Q1, Q2, Q3, max, min, etc., which is fairly common. Okay, box and whisker diagrams for me are fairly common in the IB test. And this skill here, which is getting the mean and discovering a data point that you're missing, is a classic. I also see that a lot, so make sure you train it a little bit. And so yeah, number 1, definitely not the friendliest exercise in the world, but worthwhile looking into to understand better how probability works, statistics works, a very complete exercise, and definitely a challenge, so I hope I helped in this case. And I'm talking by me, that is for number 1. Alright guys, for number 2, we have our good old friend Anika. And so they tell us that Anika invested 10,000 Canadian dollars in an account which earns a nominal annual interest rate of 3.4, which is compounded what we call monthly. And so for part A, we need to calculate the value of Anika's investment after 6 years. So calculate Anika's investment after how much? After 6 years. So there's a lot of blah blah here, and it's a little bit intimidating, but the cool thing about this type of exercise is one of two things. The first thing is that it's easy to identify that this is what I like to call a finance app exercise. Okay, at least once per test. And then when I say once per test, it's either paper 1 or paper 2. You're going to have a situation where you need to solve using the finance app. And the second thing that is useful that I kind of already mentioned is that they do ask this once per test. Okay, so because they asked this once per test, if it showed up in paper 1, it probably won't be in paper 2. But if it didn't show up on paper 1, it will be on paper 2, period. And that's the same actually for something like Voronoi diagrams, where for this year, 2025 May, time zone 1, Voronoi diagrams was not on paper 1, and it for sure appeared on paper 2. So that's the kind of exercise that will always appear at least once per test. If not on paper 1, it will be in paper 2. And so the nice thing about finance app exercises, it's that they're also easy to identify. And so it's easy to identify because you see words like invested, you see words like nominal annual interest rate, you see stuff like compounded monthly, investment again, maybe they give you years as a time period. All of this is a big hint that you have to use the finance app. Okay, so a lot of this is translating the little bits of information they give you into the finance app. And there's actually a very friendly method for understanding how the finance app works, which is new in respects to my other videos, which is a little bit harder, but also more flexible in order to face every situation. So this time my explanation is going to be a little bit tougher, but it's also going to leave you with a more dynamic tool. Así que, for accessing the finance app, you go into the graphing calculator, you press this apps button, and you go to this finance thing right here. And so the finance thing right here, you're going to pop the first one that says TVM solver. And essentially, we have to understand what each of these things mean and then translate the information they gave us into these variables here. Now, the intuition I need you to have is that no matter what they ask you to do, you're going to be plugging in everything except one of these. So you plug in everything except one of these, and that's the one you're quote unquote solving for. And so here, for example, when they say that we need to calculate the value of Anikas's investment, because it's an investment, well, it's something she's going to get later. So immediately we can say that we need to calculate FV. So let me write up here everything. So we have big N, then we have I%, then we have this thing called PV, then there's PMT, then there's FV, and then there's the two weird ones, which is PY and CY. And so the idea is that we're going to give you or end up with an intuition for each of these and go from there. All right. So big N, I need you to think about it as like the amount of payments. Amount of payments. And so usually this is going to be something like years times I would actually have you think about it like this. I would think about it as years times P/Y. But have the intuition that it's your amount of payments. I% will always just be like your interest rate percent. So that one is usually pretty obvious. PV is going to be your initial value. Formally, you call it present value. PMT, I need you to have the intuition that it's just like an sort of like extra monthly payment. All right. FV is what we will call our future value. So you have your initial value and then your future value. PY is going to be your, think about it this way, payments per year. That's why it has a /y. It's slash for year, so payments per year. And CY, it's going to be your compounding per year. Now, once again, this is a very sort of intuitive approach. Definitely a little bit more complete than other times I've explained this. But it's a more flexible sort of strategy that allows you to face more exercises, okay? So in this case, let's go piece by piece, all right? Big N is amount of payments, which will be years times PY, and we define the PY as payments per year. And so in this case, how many payments do you do per year? Well, because there isn't exactly an extra monthly payment, because there isn't anything about anything being extra, okay? Yes, you do have the compounded monthly, but there isn't something like there's an extra payment she makes at the end of each month or something like that, we're just going to assume that PY equals CY. And so that is a big step that we just did. So if no PMT, you can conclude that PY equals CY. So that's the first step we have to establish. So basically, if there is no PMT, PY equals CY. If there is a PMT, you have to consider looking PY and CY as different. PY will be payments per year and CY will be how many times you're compounding per year. So if no PMT, which is our case, PY equals CY. And so compounded monthly, that means that we end up with PY equals CY equals 12. Why is it 12? Because how many months are in a year, since it says monthly, there are indeed 12 months in a year. So PY equals CY equals 12. That's the first thing we can establish. The second thing we can establish is that Anika is investing 10,000. And so think about it this way. This is your initial value, right? It's your initial sort of scenario. And if Anika somehow has $10,000, good for you, Anika. Because she is investing, think about it this way. The second she invests, $10,000 is leaving her pocket. And so something important for the finance app is that you have to take the perspective of the person. So point of view of the person. And so if you're taking the point of view of the person and it's an investment, initially our good old friend Anika will actually be losing $10,000. And I know this might be weird for some people because you say, well, isn't she investing? Isn't she going to earn money? Yes, but initially, the first second that she invests this money, that money is leaving her wallet and entering the bank. So PV will have a negative symbol here. This is very important. Okay? Perspective from the person, positive and negative symbols. It's very important that you are consistent. And the best way to be consistent, or it's my tip, is always think the perspective of the person. Anika initially loses $10,000. Yes, she's investing, but initially it leaves her wallet. So that would be PV. We already defined PY and CY. We have to actually discover FV because they're asking for Anika's investments. So FV is something that we're trying to discover. So check on that sense that we already defined it as something we have to discover. Then they tell us that the interest rate is 3.4. So that already gives us this I%. So I% is going to be literally 3.4. And now the hard one, which is N, which is amount of payments, which I'm saying is years times PY. Because there's no PMT, PY equals CY, and it's easier to understand CY, which is compounding per year. So PY equals CY, CY is compounded monthly, CY equals 12, so it's going to be years times 12 in this case. And for how many years is it happening? 6. So that means that big N is going to be 6 times 12. So let me pop all of that into my calculator. So big N is going to be 6 for years and then 12 for compounded monthly. Your percent is going to be this 3.4 that they mentioned. Your PV is initially negative 10,000 because it is an investment. PMT, there is no PMT because there is no sort of extra monthly payment. So you just leave it on 0. FV is what you're trying to discover. For now, leave it on 0. And in this case, because there's no PMT, we're going to leave PY as CY. So 12 equals 12. And bada bim bada boom, that means that PMT from here, that means that we need to discover what FV is. Ahora, the finance app is not like other functions or whatever where you press enter and you get the answer. What you actually have to do is tell the calculator, oye, with all these numbers I plugged in, what should FV be? And so it's basically, you're telling it to solve for FV from here. How convenient, there's a solve button here in green. So you press this green guy, press enter to help that solve while standing on FV. And you see this little square shows up. It's telling you, oh yeah, I tried discovering FV with all these parameters, that you gave me. So FV in this case is this number. 0.44472. Don't forget your units in CAD. And if we check over here the answer key, it looks just about right. over here. 12,259, 12,259. Bada bim, bada boom. As you can see, there's a bunch of different ways you can try to solve this. There's even a compound interest formula you can use. But my suggestion is that you stick to the finance app always. Why? Because this compound interest formula, it helped you for part A, but there's nothing about that in part C, nothing in part D or later. And so the finance app always works. The compound interest formula, not always. And so you get quick suggestion, avoid the compound interest formula, master the finance app. And talking about mastering the finance app, there will be more than one way to solve this. See? And the way that I suggest that you approach these exercises is with this stuff I wrote up here, where the first step you have to do is first identify if you have no PMT. So no PMT, you say that PY equals CY. If there is a PMT, remember that PY is for payments per year, while CY is for compounding per year. And so for me, this is the hard part, and also establishing what big N is. So as long as you sort of memorize that it's years times PY, you should be good to go. Enough talking for part A, let's move on to part B. We have that Anika wants to purchase a house. Lucky for her. Not everyone can do that nowadays. Flipping boomers. Anika wants to purchase a house that costs $225,000. $225,000. Anika uses the value obtained in part A, ojo, to make an initial payment on the house and take out a loan to pay, and this is massively important, the rest. And so what is the value of Anika's loan? It's worth 1 point. So this is the kind of scenario where you just gotta trust your gut. The cost of the house is $225,000. And they literally tell you that the value obtained in part A, which is stuff she earned from investing, was this $12,259, and that she will be taking out a loan to pay out the rest. So this is the cost of the house. This is how much she earned by investing those $10,000. And so the loan ends up being this $225,000 minus this $12,259, which gives you $212,741. $212,741 CAD. And so the loan ends up as $212,741. There's the $212,741. So thus far we all agree. Part C is where it gets juicy, and it is worth 5. And so this is where the real challenge begins of, do you really understand the finance app? Okay. The cool thing about the finance app exercise is that it always shows up. So if you learn this well enough, you should be able to tackle most of the exercise. Okay. Notice that part A and B is part B is intuition, part A is understanding the basic functions of the finance app, and part C is where it gets more exciting. Ahora, ¿por qué? Why does it get more exciting? Because Anika amortizes her loan over 15 years, which is already scary to hear. What the heck is amortize? Intuitively, just think about it as like she's going to pay the loan over 15 years. So this is already a big hint. We're talking about 15 years. Earlier, it was 6 years. And so notice that we're talking about 15 years now. And this is the tricky part. So read carefully. She arranges to make a loan payment at the end of each month. So let's stop there for a second, because this is the reason this exercise is worth 5 points. This is a thing that a lot of people don't fully understand. So really concentrate. When it says at the end of each month, and later on it also tells you that there's a blah 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 annual interest rate 6.4 and compounded half yearly, think about it this way. You have two components. Your first component, which is your classic, is the compounded, and your second one are these payments. And so earlier we only had compounded monthly, which is when we had this scenario. No PMT, PY equals CY, yada. Part C, we have the compounded half yearly, but we also have these payments they're mentioning here, which conveniently will always say something like at the end of each month. These words here, at the end of each month, repeat a lot, which is a massive hint for understanding that there is a PMT. Now, part C is actually asking you to determine Anika's monthly payment. It's literally asking for what the heck is PMT in this case. And so this is where it gets juicy, where you have a compounded portion and the payments portion, you have PMT. That's basically what's happening. But with these sort of definitions I gave you here, it should be easier to face. I know it's more to remember, but it should be easier to face. Dale? So let's go piece by piece one more time. So for part C, we need the big N, which is amount of payments. ¿Cierto? So amount of payments is going to be years times P/Y. So in this case, we're talking about 15 years. So up until then, we agree. But P/Y is a little different. ¿Cierto? If there is PMT, PY does not equal CY. See, so here I'm saying if no PMT, PY equals CY. If there is PMT, PY will be payments per year. CY will be compounding per year. So of these payments that are at the end of each month, how many per year? Well, because they're at the end of each month, you can sort of think about them as monthly, which is actually pretty much how they always are at the AISL level. But yeah, it happens once at the end of each month. So that means that PY will actually be 12. So I'm actually going to write that down somewhere here. So PY, we can establish it as 12. So that means that big N is 15 times 12. I% is still going to be the nominal annual interest rate. So you're going to leave that as 6.4. Yet still, PV is your initial value, which here they're telling you it's a loan. And so it's a loan which is at 212,741. So that is how much she owes. So your PV, in this case, perspective from the person, it's how much the loan is. Okay, so it's going to be as a positive value. You're going to understand why in a second. So it's a positive value how much she owes the bank because it's a loan. PMT is what you're trying to discover, so I'm going to leave that as a question mark. FV is your future value, and this is the big brain moment. If you have a loan, what value do you want it to reach? If you have a loan, the value you want it to reach is 0. And so notice, PV is positive 212,741. FV will be 0. And your PMT will have to be negative. So it's some negative value. We still don't know which one, but it's some negative value. So example, yes, the loan is 212,741, but these monthly payments, which are negative value, which applies continuously to this, will eventually make it reach 0. So that's why the loan, we think about it as a positive value, and the PMT has to be negative on the other end. So it's important that these two symbols are different, PV positive, PMT negative. Or you could have thought about it as PV negative and PMT positive, but you have to be consistent in the sense that they're opposite symbols, PV and PMT. That way they always reach an FV of 0. That's like the big brain play, which actually here does appear that you need to FV0 is important. And well, this is for part D, but the logic still applies. PV and PMT must have opposite signs. See? So that's like a more conceptual sort of approach that is very important to have in mind. Anyways, the last thing we have to define is this famous CY, where it defined PY. And so CY, we said, is compounding per year. Here it's compounded half yearly. So half yearly means how many times in a year? It means twice. So CY equals 2. From here, not entirely organized, but this is what we're plugging in. So if I go over here and go into the finance app, this is what will help me discover what PMT is and Nika's monthly loan payment. So big N is going to be 15 times 12 because again, it's years times your PY, which is payments per year. Your I%, we will always leave it as they give it to us because it almost always says nominal annual interest rate. So you just leave it as 6.4. We pretty much never change that in my experience. PV will be positive 212,741. PMT is what we're discovering, so I'm going to leave it empty. FV, because it's a loan, you want it to reach 0. PY, we leave it as 12. And CY, compounding per year, we leave it as 2. So from here, you pop alpha, enter for solve. And that gives you this negative PMT value, which makes sense. This amount of loan will be decreased by this monthly until it reaches 0. If you wanted to think about it in the other way, maybe it's easier for you to think like, oh, Anika lost money and owes all this money, so it's negative 212, 741 how much she has to pay, and she's going to pay monthly a positive amount so that it reaches 0. Then yeah, you can solve it like this too, and it's the same answer, just that with a different symbol. Both of them work. Don't stress out about that. Just be consistent, okay? Just be consistent with how you think about it, and always think about it the same way, so that, you know, the exercise is a little bit easier. So PMT in this case ends up as that 1831. If you round it up, you can leave it as 1832, which is exactly what the answer key did, just around over here. So that would be for part C. So notice, just understanding what PMT is helps you get 5 points. It's crazy. I feel like, for me at least, amount of study hours and the amount of points you're probably going to gain is very friendly for the finance app. So especially if you're like trying to claw for like that 4 or 5, consider studying for the finance exercise, because it tends to be a lot of points and not that much study time. You just have to master the finance app. See? Stuff like, I don't know, the chi-squared and this or that has a lot of more variations. This is like, you get a 4 or 5 if you don't understand PMT, you get a 6 or 7 if you do. And so that is why it's less effort for more points, speaking, like relatively speaking. All right, let me make a little bit of space for a good old friend part D. So after 2 complete years, our good old friend Anika decides to increase her monthly loan payment to 2,200. Okay, so notice, after 2 years, she decides to increase her monthly loan payment, so that would be the PMT, to 2,200. So remember, monthly loan payment is this PMT. Same here, loan payment at the end of each month, monthly loan payment, same thing. Vale? So PMT now equals 2,200. And it says 2, so it's literally 2,200. If it would say by, we would be adding, but because it says 2, PMT is now 2,200. And they told us that at the time, the remaining amount of the loan, so remaining amount loan is this, 194,572. And so for part DI, we need to calculate the amount by which the loan will decrease during the next 3 complete years. So 3 years is basically what we're trying to calculate from here. So conceptually, the challenge is big, but intuitively we can figure it out. See? So the first thing we can sort of establish, okay, so let me put everything on 0 and go bit by bit, except for the stuff that is a little more obvious, ¿cierto? So the stuff that is obvious is that our I% has not changed. So it's still 6.4. We still have the monthly payment of 12, and it's still compounded half yearly, so the CY is still 2. So these are the 3 things that remain the same: the 6.4, the 12, and the 2. So that's the first step we can sort of do intuitively. The second thing we have to establish is that PMT increased to 2,200. So PMT aquí va a ser 2,200. Then they also tell us that currently the remaining amount of the loan is 194,572. So PV will be this negative 194,572. Notice that here I'm doing a negative PV and a positive PMT, knowing that we're aiming for it to reach 0. Así que ojo con eso. Ahora, in this case, we actually need to calculate the amount of by which the loan will decrease. So we will actually be discovering the loan value that it reaches, okay? But intuitively, the main thing is that PV and PMT have to have different sort of values, okay? Originally, we said that we will leave PV positive, so we're going to do that. But as long as they have different symbols, you're consistent. Yeah. So I'm going to think about it like this because it's what I prefer, but you can do whatever you prefer, whatever floats your boat. Yeah. And from here, the next big challenge is understanding N. And we said was going to be this amount of, it is your amount of payments. And the formula is going to be years times PY. So because PY is still 12, And because it's asking for us to understand after 3 complete years, because it's after 3 complete years, that means over here we're going to have 3 for years times 12 for PY. So it's 36 payments. Makes sense. And all of this just to calculate the amount by which the loan will decrease. So in how much does the loan end up after 3 years? That is going to be FV. So after 3 years, FV is that. And this amount looks a little bit weird. Negative 148,000. All right, it's a little bit funny that it shows up negative. I'm not gonna lie. But we know that the loan ended up being that. Cierto? I mean, you can sort of think about it as a perspective person. It's how much the loan still is. I'm just gonna say it right away. Context is important for these sort of symbols, positive or negative. You gotta be consistent with PV and PMT being different because conceptually that's how it is. But from here, understanding the exercise, you can say that sort of like initially, the loan was at this 194,572. And then after 3 years, it ended up at this value here, so the 148, 0.98. Ahora, because it's 0.98.99, I'm just going to leave it as 0.99. All right. And so part DI is asking for us to calculate the amount by which the loan will decrease. So by how much did it decrease? Well, if initially it was 194,000 and after 3 years it reached 148, well, it decreased by that amount. So 194,572 minus the 148,099 is by how much it decreased. And so that gives us, if we pop that into the calculator, so 194,572 minus this 148,099 ends up giving you this 46,473. The other thing that is worth mentioning is that these finance app exercises, you will end up with these weird numbers. It's not something nice like 475 or 470 or 480. No, it's 473. It's not nice, and that's normal. Okay. So DI over here, we do end up with that's 46,473, 46,473. And so plugging in, it was important to have clear that PV and PMT must have opposite signs. Así que, yes, we ended up with a, yes, the calculator gave us a negative 148,000, but using the context, we know, we know that that was the loan after 3 years. Yeah, so you can keep that sort of stuff in mind. It is fairly relevant to understand it well. Always apply context of the exercise. It helps you understand your calculator as well in times like these. And last but not least, part DII is extremely hard in the sense that it's an awfully specific sort of context. Concept. So for part DI, it's asking you to determine the total interest that an equal will pay over this 3-year period. Now, I'm going to say right away, for me, DI is like if you're going for a 7. Okay, this is not the sort of part of the exercise that you should normally, quote unquote, know. For me, the stuff that you should normally, quote unquote, know is parts A, B, C. Because A is understanding the finance app, B is like some random context thing, and C is understanding PMT. Part D is just challenging. Okay, it's challenging you conceptually, and part DII is just awfully specific. You either know it or you don't. Okay, that's the sort of spirit of part DII. So don't stress out on this part. I actually myself had to think about it a lot, research a little bit. It's not the friendliest thing. See? So you have to determine the total interest, and so you have to think a little bit about the interest formulas that you have at hand. And so conceptually, how I would like to introduce it is that in general, when you make out this loan, okay, you have your total payments you have to do. So I'm actually going to write payments here. See? So your payments to the bank are two things. You can think about it as like your original sort of like defined amount, which would be, you know, like you can think a little bit as like the flat rate that happens. It's your part of the payment you make to the bank is the original that you agreed compounding. Okay, and then the other part is going to be the interest you pay to the bank. And so think about it this way. It's like if you take a loan from the bank of like $100, and so they tell you, oh, okay, yeah, every month pay me $10 back. And you say, oh yeah, perfect. So after 10 months, I'm done. And then they tell you with a 5% interest. Your original would be those $10 every month. And your interest would be, well, that 5% that we mentioned. And so your payments will always be your original plus that interest. Okay? And so using this formula here, because you need to determine the total interest, you need to try to plug in, using this formula, your payments and this original that we're talking about here. And so the payments ended up being this $46,473 from part DI, which is also useful to know that in general, when you have something that has two parts, like I and double I would say like 90% of the time, part double I needs something from part A. So that's also a nice little hint that could help you figure out this exercise. Also just a good test taking strategy for the IB math exam. Part double I almost always requires something from part I, which is friendly to know. See, almost always. So your payments were $46,473 because it's by how much the loan decreased. So it makes sense that those were your payments. And then our original sort of payment that we did was this famous PMT that we added onto it. ¿Cierto? So this $46,473 were your payments, and part of it was this PMT. Now this PMT was $2,200, and it applied how many times? It applied big N amount of times. So it applied monthly because it's PMT, and for how many years? For 3. And so this is the original value that we're talking about. So payments is this 46,000, original is this guy here, and then interest is what you're still trying to discover. And so from here you end up with 46,473 equals whatever that is. So it's 2,200 times 12 times 3, 79,200 plus this interest. So that means that interest will equal to, you can do this 46,473 minus the 79,200. And I know that here it's going to give me a slightly negative value. So maybe conceptually I could have done it a little bit better. But it is what it is. Let's just apply the context. So this minus this gives us this 32,727. And so we understand that the interest had to be this amount. The expression or the intuition comes from all the way over here. And bada bim bada boom. As you can see here, you did have to do that, the 79,200 minus the 46. So you end up with this CAD here, the 32,727. I know that I ended up flipping these here, but again, applying the context much how I did earlier, where I got a negative FV for part C, I think for part DI, I think it was. ¿Cierto? Just applying context is important always, especially for these where you end up mixing the positive and negatives. It happens all the time. It happens to me. For the method, I wouldn't worry too much, because for the method points, as long as you're consistent, like PV and PMT being opposite signs, you're good to go. And so in this case, I wouldn't stress too much about it. You can just conclude. You can tell that you know this formula, okay? And you end up with this interest here. Logically, you leave it as positive, because leaving it as negative would be that the bank pays you. Así que, yes, I'm sure there was a slightly more accurate way to do this, but I'd rather leave it more intuitive and also show you the test taking strategy. Do what makes sense. We're going to leave it positive. enough talking by me. That would be for number 2. That would be the finance app exercise for this test. Remember, if it didn't show up on paper 1, it will show up on paper 2. And the challenge for those extra points is understanding this PMT thing, which if it shows up, it will say something like at the end of each month. That's the keywords you need to look out for identifying PMT and also identifying the correct sort of methodology or approach. Anyways, once again, enough talking by me. That would be for number 2. All right, guys, for number 3, we have that Felix is training for a competition consisting of running and swimming. He plans to train for 12 weeks to prepare for the competition. The running part of the competition is a 5-kilometer race, and during the 12 weeks, Felix runs 3 days each week, and they put it in bold for a reason. Ojo, on the first day of training, Felix runs 2 kilometers. So first day, 2 kilometers, and each subsequent day, we'll talk in a second what that means, each subsequent day that he runs, he increases his distance by 5%. And already in part A, we need to explain why the distances of each of Felix's runs form a geometric sequence and state what we call the common ratio. So this, of course, is what I will call a sequences exercise. And the cool thing about a sequences exercise or a sequences problem is that it does show up once per test. Okay, if it didn't show up in paper 1, it will show up in paper 2 and vice versa. Okay, the sequences that you can encounter are on the one hand what we call the geometric and also the arithmetic. All right, and if for some of you this might be relatively new or you're remembering from class or whatever, I strongly suggest that as a general sort of attitude that you have towards this test is that you really have to master the formula booklet. Now, why would you master the formula booklet? You master the formula booklet because the day of the test, you're walking in with a pen and pencil, 2 years of experience of this thing called the IB, 2 hours of sleep, a whole lot of motivation, your graphing calculator, and the formula booklet. Así que the graphing calculator and the formula booklet are the 2 things you have to really master. It's not enough to have the tool. It's important to know how to use it, what's in it, what are the capabilities. And so the moment you identify you are in a sequences problem, well, go to the sequences portion of your formula booklet. As you get from here, you can see that in the sequences portion of the formula booklet, we have up top 2 things for arithmetic, and on the bottom, we have 2 things for geometric. Geometric. And in both scenarios, because there's 2 formulas, in both cases, one of them is for what we call the nth term. So it's whichever term you're trying to find, whether it's the first, second, third, or fourth, you can use this nth term sort of approach. And the second thing is what we call for the sum of n terms. For now, I'm going to just highlight sum. All right. So you have one equation for nth term for identifying quote unquote any term, and another equation for the sum of n terms. Ahora, part of understanding these formulas, I'm going to go explain this for a second, which is going to make the exercise a lot more friendly or friendlier. Okay. Taking a look at the arithmetic sequences portion first, you have U1, N, D, and UN. Okay. And N is going to be your nth term. So whether you're looking for the example, let's say you're looking for the 5th term. So if you're looking for the 5th term, that means that N equals 5. And if N equals 5 here, that means N equals 5 there as well. And so plugging all of that in, you would end up with something like U5 equals U1 plus 5 minus 1 times D. So that's the first thing I'm going to explain. When you plug in N, you also plug it in little n here. Okay? That goes for all of this. And the second thing I'm going to sort of explain is that U1 would be obviously the 1st term. So this is 1st term. And depends on the scenario, what you're looking for. And D in this case, D for common difference, which is an important distinction from the geometric world where instead of D, you have R. And this R is going to be for common what? common ratio, or at least this is how I remember it. Over here they mentioned it as well common ratio. So you can see that here common ratio for R means that we're going for this this R value here, okay? The last thing I'm going to mention is that for the sum formulas, for the arithmetic ones, there is a semicolon. And so if there's a semicolon, it's telling you out loud these two equations are a little bit different. And this is an important thing to watch out for. This is the kind of thing that leads you to master the formula booklet. It's just knowing that there's a difference between these two formulas. It's not remembering what the difference is. What's important here is remembering that there is a difference. And so the day of tomorrow, we are trying to find the sum of arithmetic sequences. It does matter which one you go for. And intuition is that the one on the left asks for n, asks for u1, and asks for d. So plugging in n, u1, and d, you clear everything on the right. But for this other version of the equation, they ask also for n, they ask also for u1, but they do not ask for d, they ask for un. And so slightly small difference that can save you the day of the test. One of them asks for the common difference, the other one for un. So depending on the exercise, they might give you one or the other. You got to use one or the other equation. I think a small difference, but it can save you a couple points. And for the sum of geometric sequences, there is literally an equal sign. And so they do ask for the same stuff on both sides. It's just rewritten in different ways, but just looking quickly, you can tell that both of them require u1, both of them require n, and both of them require r. And so nothing different between one or the other, rather than they're just sort of like flipped. So you can see how it's flipped. Which mathematically it's the same thing. So I don't really know whether IB tries to trick us like that. But it's relevant for us to know that the arithmetic sequences one does have a subtle difference. All right, enough talking. And the last thing I'm going to mention, which I should have mentioned initially actually, when we talk about arithmetic sequences, it's a sequence that is affected by adding or subtracting. When we have a geometric sequence, it's something that it's affected by multiplying or dividing. And so identifying those sort of differences can be very important. Let's go back over here and now let's talk about part A. It says, explain why the distances of each of Felix's runs form a geometric sequence and state the common ratio. And so the intuition I just shared with you is that arithmetic is adding or subtracting by a flat amount. And when I say flat amount, it's like a fixed amount that's not going to change. Okay, maybe that's a little more intuitive actually. I'm going to write here fixed amount. So arithmetic sequence, it's like, I don't know, I ate or I won one Valorant game today, and tomorrow I'm going to win one more, the next day one more. So then on Monday I win one, Tuesday I win two, Wednesday I win three, so on and so forth. If it were something geometric, it's not a fixed amount. I mean, it might increase by the same amount always, yes, but your increase would be percentage wise. And so it might be a fixed percentage, but the increase isn't by a flat amount. Okay, so this would be something like, I don't know, every day whatever, I get 3% taller, I don't know. And so the first day maybe it's 5 centimeters, then the next day it's 8 centimeters, then the next day it's 11. And so you can see it's not always plus 5 plus 5 plus 5, but rather it was plus 5 plus 8 plus 12 plus 17. It doesn't always increase by the same amount, ¿cierto? So that's the difference between arithmetic and geometric. Coming back to reality, part A, explain why the distances of each of Felix's runs form a geometric sequence and state the common ratio. It's worth 2 points. So one of them is going to be the geometric sequence. The other one is finding the common ratio. So in this case, I would say something like geometric sequence because it increases by a percent instead of a flat amount. And the other thing we can mention is that the common ratio equals 1.05. Now, how did I reach that it is 1.05? I reached that as 1.05 because here it says that it increases by 5%. And so the step in between that I need you to do is that you're going to write R equals 1 plus whatever they give you. And so because it says, or actually let me even go a little bit further back. You're going to write R equals parentheses 1. And if it says increase, you will put a plus. If it would say decrease, we would have put a minus. In this case, we're going to put, that's definitely not a minus. So if it says increase, you put a plus. If it says decrease, you put a minus. In this case, we put plus. And because it says by 5%, well, you're going to put 5% here. And how do you express 5% as a decimal? Bueno, remember that 1 is 100%, that 0.5 is 50%, so that means that 0.05 is 5%. For converting from percentage to decimal and decimal to percent, technically you're just multiplying or dividing by 100, but intuitively, at least for me, I'd rather remember these three cases and you can figure anything out. So from here, if I tell you, how do you express, I don't know, 7.2% as a decimal? Well, you know that 5% is expressed as 0.05, so it's going to end up at 0.07, and then it's going to have to go the 2 right there. So that's why I think that intuitively I'd rather have you guys remember this. Coming back to reality, increases by 5%, so 1 plus this 0.05, which means that you end up with R equals 1.05. Bada bim, bada boom, common ratio is 1.05. Over here we can see that for part A, it says R is 1.05. And the explanation, okay, the explanation says the ratio of consecutive terms is constant. Okay, so the key word here that you would give is the word ratio. And on the second part is each term of the sequence is found by multiplying. And so identifying that it's multiplying, it's showing that you understand the concept that geometric is multiplying or dividing. In this case, I said geometric sequence because it increases by a percent instead of a flat amount. I could have done better. And I'm leaving this in the video because it happens to anyone. But what I should have focused on a little more is maybe say something like geometric sequence because it increases by a percent that multiplies instead of adding a flat amount. And so there I'm showing that multiplying is for geometric while adding is for arithmetic. So I think I definitely could have put a better answer, and I'm glad this happened because it goes to show that the key difference or key idea between geometric and arithmetic is that arithmetic is plus or minus, geometric is multiply or divide. Yeah, that would be for part A. Part B says find the total distance of Felix's first 15 runs. So here it says total distance. That's already one hint. And the next hint is that they're talking about 15 runs. Ahora ojo. I have two formulas. One of them is for nth term. Actually, we're talking about geometric, so I'm going to go down here. One of them is for nth term. Another one is for sum. And so if it's saying total distance, is this for nth term or is this for sum? Because it's total distance of the first 15, it's a big hint for sum. So we will be using the sum formula in this case. And the sum formula for the geometric one, both versions work, and both of them ask for U1 and an R. And so notice how the method is important. You identify as geometric, you identify that the variables you need to find, so U1, N, and R, and once you have U1, N, and R, you can plug in more easily. Así que let's go ahead and attempt to define that. U1 has to be this, N has to be something we still don't discover, and R, we already got it, so R is 1.05. So R is 1.05, N is gonna be the sum of whichever term we're like sort of going for. And so because we're going for the first 15 runs, okay, because we're going for the first 15 runs, we can leave it as n equals 15. And how do you know that it's n equals 15? Because here it says that on each subsequent day, he increases his distance by 5%. So on each day, like one day would be the first term, second day would be the second term. So that means on the first 15 runs, first 15 days, n equals 15. And last but not least, U1 is going to be his starting point. And the starting point, his first run, here it says on the first day of training, Felix runs for 2 kilometers. So clearly U1 has to equal to 2. So all of this plugging into our equation, important to put the equation to show that you're, getting that method point showing your work. We can write S of n. That looks like 5 of n. So S of n, which in this case is actually S of 15, because we are plugging in n of 15, so S of 15, so the sum of the first 15 equals, I'm going to use this version, ¿vale? Equals U1, which we defined as 2, parentheses R, which is 1.05, to the power of, I think it was n, n, so n is as 15, minus 1, close parentheses, divide by, I think it was R minus 1, ¿cierto? R minus 1, so 1.05 minus 1. So all of this into your calculator should give us the answer. Because it's a fraction, I suggest for plugging in more easily that you press alpha y equals and pop the first one to put a fraction. And see here we can do 2 parentheses 1.05 to the power of 15, drop down minus 1, and then in the denominator 1.05 minus 1. So all of this makes it a little more friendly to face. And so S of 15 ends up being 43.1571. 2718. And if you want to do significant figures, you would go like this. 1, 2, 3. Do you round it up or keep it the same? You round it up, so you could leave it as 43.2. What are my units? Kilometers. Wow, that's a lot of kilometers. Congratulations, Felix. Así que, let's check our work. Here we reach the 43.2, and you can tell that a method point is simply attempting to substitute into the geometric sequence. So this is why it's so important to understand the method, to also understand the formula booklet. Just trying to plug into the geometric sequence already gives you 1 point. Maybe you plug in horribly, you don't get the answer, this or that, but just attempting to put in the stuff into the geometric sequence already gets you 1 point. As you can always claw for points, and I always suggest method points. So having clear which formulas to use when, the formula booklet, the tools in your calculator, all of this can net you method points, and you can get the wrong answer, but you get half the points. I mean, even here, notice, well, this is reasoning, so that's different. But for part B and C, in both cases, it's worth, well, here it's worth 2 points, here it's worth 3, but they both have at least 1 method point. As you can notice, you can get the right method, but the wrong answers, and still get maybe a 4 in the test. Assuming you get a bunch of method points and always the wrong answer, you would get a 4, which is pretty impressive. As you can go for method points, always worth it. Yeah, that would be for part B. Then they tell us that a published recommendation states that on the last day of training, an athlete should run a distance that is at least twice as far as the race distance. Así que ojo, last day of training, an athlete should run a distance that is at least twice as far as the race distance. And so all of that being said, for part C, we need to show that. And so, ojo, any show that exercise means that all of this is true. Which in this case, it's not particularly useful, but maybe for some other exercise, knowing that this is true can unlock something for part D. Not in this exercise, but it's important to know that show that is basically prove that this is true. And so it's telling you that it's true, and you can use that information for part D. Anyways, show that Felix's final run of his 12-week training plan meets this recommendation. Así que, the big question here is which run is it at the end of the 12-week plan? And a lot of people immediately jump to say n equals 12, and they plug in and see what happens. And I understand why you would do that. Pero ojo, they did put something in bold earlier. That was that Felix runs 3 days each week. And so if he ran, or his training plan was 12 weeks, Well, how many times did he have a training session? How many times did he have a running session? If it was 3 days each week and the thing lasted 12 weeks, well, per week he ran 3. Per week he ran 3, so he ran 36 times. So Felix's final run is his run number 36. So that's the first big brain thing that they're challenging you to identify, and in this case is 36. And the other thing we have to talk about is that here, it's not talking about sum, it's talking about how much he ran on the last run. How much he ran on the last run, claro. Why? Because the published recommendation states that on the last day of his training, the distance that he runs on that last day has to be twice as far as the race distance. Okay? As he gets not the sum of the 36 runs that he did, it's only the last run. And so if you're trying to identify only the last run, it would be the nth term of a geometric sequence. So it would be term number 36. So let me write down that equation for a second. The equation is un equals u1 times r to the power of n minus 1. And so in this case, because n equals 36, and because I still know that u1 is 2 from earlier, and that r is 1.05 from earlier, we just plug in. So u of 36, basically the last one, has to equal 2 times our r to the power of n minus 1, so 36 minus 1. So plugging all of that into the calculator, you end up with 2 parentheses 1.05 close parentheses. Pop that thing up there, 36 minus 1. 11.03. So he ran 11.03 kilometers on his last day of training. So U36 equals 11.03 20 30 20 30 74. And once again, if you want significant figures, you count 1 2 3, round it up or keep it the same, so you can leave it as 11 kilometers. Ahora, this was for identifying how much he ran on the last race. What we need to show that is that Felix's final run, which is this 11 kilometers, meets this recommendation. And the recommendation was that an athlete should run a distance that is at least twice as far as the race distance. Así que, what is the race distance? The race distance, ladies and gentlemen, is 5 kilometers. 5 kilometers. And so from here, clearly 11 kilometers is greater than 5 kilometers. So bada bing, bada boom, you're good to go. And you're finished with part C. However, reaching only this, it's not a mistake, but you're losing a point. What? How am I losing a point here? It's so obvious that 11 kilometers is twice as big as 5 kilometers. Yeah, but here, guys, it says show that. And so if it says show that, you gotta give me a reasoning. And so it's very important that at the very end of this exercise, you express somewhere on your paper that 11 kilometers is greater than 2 times 5 kilometers. 11 kilometers is greater than 10 kilometers. That would be your reasoning. And I'm pretty sure it's part of your answer. And so you can notice, one of your points was identify n equals 36. That's the first challenge. The other point is attempting, once again, just attempting to plug into the geometric sequence formula, term formula. And then the last point is literally saying 11 is greater than twice 5. Or saying it verbally or whatever, ¿cierto? As you can notice, it's not enough to reach the 11. You have to compare the 11 to the 5 times 2 because it does say show that, so you gotta give reasoning. Así que that's another small hint to keep in mind. The other way you can, maybe some of you are asking, okay, how do you know you have to do that to get a point? Well, on the first hand, it says show that. Así que if it says show that, you gotta give reasoning. But the other way that I like to identify that you're gonna go a little bit farther is that it is worth 3 points. And so if it's worth 3 points, At that stage, there's got to be some sort of reasoning or answer or whatever thing you have to mention. See? If it's worth 2 points, it's probably like one answer and one method. If it's worth 1 point, that's a whole different story. And if it's worth 3, then yeah, you probably have to go a little bit above and beyond. Enough talking by me. That is for part C. Then we enter what we call the swimming part of the competition. So for the swimming part of the competition, competitors must swim 375 meters out to a marker in the water and 307 meters back to the shore. And so good old friend Felix has a lot of time and plans to swim 2 times per week. In addition to 3 days per week running, well, Felix is determined, my guy. I respect you, Felix. Hell yeah. So Felix plans to swim 2 times per week to train for the swimming portion of the competition. On each day, and this is where it gets a little bit juicy, so take your time reading. On each day he swims in the first week, Felix swims out to a marker that is 80 meters from the shore and then swims back to the shore. So he swims out 80 and then back to the shore 80. The next part says that at the start of each subsequent week, and so earlier notice we talked about subsequent days, now we're talking about subsequent weeks, the marker is moved to increase the distance between the marker and the shore by a constant amount. Felix swims a total distance of 704 in the 4th week. And so here they're literally just giving you this random sort of point of information that Felix swims a total distance of 704 in the 4th week. And the cool thing about the IB is that they never give you a random piece of information. All information is useful. Whether you use it or not is a different story, but all information is useful. And so if they tell you something random like that, pucha, think about how it can enter your formula, how you can make use of it, etc. So the distances that Felix swims each week form and they literally tell you an arithmetic sequence where each UN is, in bold, the total distance he swims in the nth week. And so the challenge here is that earlier we were talking about subsequent days, now we're talking about subsequent weeks, and even UN is the total distance of that week. And so this is definitely harder to think about. And the hard part here is understanding you're talking about weeks and not days. It's a little bit harder to visualize, but we're going to try our best. Now, before jumping into part D and E, I'd like to point out the following. This is a general tip for paper 2. Paper 2 might be a little bit scary because one exercise has how many parts? A, B, C, D, E, F. It goes way farther than paper 1. But the cool thing about paper 2 is that almost all these exercises, you can cut them in half. What do I mean by this? Even this one here about our good old friend Felix, you can solve ABC as like the first half of the exercise. And ABC has nothing to do with part D and E. So that means that if you, for example, really don't like geometric sequences and you suck at geometric sequences, but later on you have something like arithmetic sequences, okay? That means that you can skip ahead. You can skip A, you can skip B, you can skip C, and go ahead and solve the arithmetic sequences portion. Así que paper 2, the cool thing is you can split these exercises in 2 and you can skip ahead no problem. So that's a good test-taking strategy. Don't look at an exercise in paper 2 and say, oof, the first half is impossible, I can't solve number 3. Maybe you can solve the bottom half of problem 3, which has nothing to do with the first part. And yeah, generally in the IB, what you need from part B is something from part A, what you need part C is something from part B, but paper 2 breaks that logic a little bit. You can cut these exercises in half and skip ahead if you can't solve the first half, whatever. It's a way to claw for points. So that's a general test-taking strategy para paper 2. Let's come back to reality. Part DI is finding U1. And so, U1, or in general, just UN, is going to be total distance of that week. So how much total distance did our good old friend Felix swim on this first week? Well, on the first week, let's read again knowing this context. Felix swims 2 times per week. And on the first week, he swam out 80 to the marker. So he swam out 80 and then back 80. So he swam 80 to reach that marker. So he swam 80 to reach the marker. And then he swam 80 back to reach the shore. So that already tells me we're doing 80 times 2. But because it's in that entire week, well, how many times does he train per week? He trains 2 times per week. So this happens twice. And some of you might be thinking, hold up a second. The second time he swims, shouldn't the distance be larger now because it's an arithmetic sequence? And I would say yes, but that arithmetic sequence applies every other week. ¿Por qué? Because here it says at the start of each subsequent week, the marker is moved. And so in 1 week, the 2 times he swims, it's the same distance. The next week, those 2 times he swims will be an increased distance. Así que, ojo, small detail but relevant detail. U1 is going to be 80 times 2 times 2. So that is 160 times 2. So it should be 320. And our units are meters. Let's check over here. Looks good to me. So just recognizing one method point that it's 80 times 2 times 2. And then the answer for multiplying correctly, 320 meters. So notice, once again, method, understanding you're doing times 2 times 2, and even multiplying it correctly still gets you 1 point. That is, you can always write out your thought process. Don't just write down 320. That would be for part DI. Part DII, we have to determine the increase in the total distance Felix swims each week. And so basically, when it says determine the increase, it's asking you to determine the common, what we call, difference. Now, how the heck do you discover the common difference here? Perfect. So what happens is that here they're telling you that Felix swims a total distance of 704 in the 4th week. So notice, small interpretation we have to have extremely clear. Because it says that Felix swims a total distance of 704 in the 4th week, it's not telling you that you're talking about the sum of the first 4. It's saying in the 4th. So instead of sum, although it does say total distance, it's the total distance of that week, because all of this is in weeks, but it's asking for in that 4th week. So in that 4th week would be U4 equals 704. That is what it's telling you. Así que over here, well, what is my nth term sort of equation? It's this guy here. It's the UN equals U1 plus n minus 1 times d. So let's write that down quickly. We have UN equals U1 plus parentheses n minus 1 plus d. And so UN, we're saying is 704. So actually, let me first plug in U4, which remember, because there's a 4 here, that means that n equals 4. Yeah, so U4 equals U1, which we said was 320, plus n, which is 4 minus 1 times d. And now I'm going to plug in this U4 as 704 equals the 320 plus 3d. So from here, solving for d, you can do minus 320, minus 320. Instead of quick maths, we're going to quickly pull out my calculator and end up with 384. So you get 384 equals 3d, divided by 3, divided by 3. D equals 384 divided by 3 gives us 128. So that is for determining the increase or the common difference. D equals 128. Finally, for part DII, we have hence, which is an important word because it's telling you, oh yeah, using what you did from part I and II, hence, calculate the distance between the marker and the shore in the 2nd week of training. In the 2nd week of training. And so for part DII, it's a little more friendly than what you think. You have that U1 is 320. And so that means that this was the total distance traveled, right? And for U2, if you attempt to discover U2, it's simply going to be U1 plus one common difference. I mean, makes sense, ¿cierto? So U1 plus 1D equals U2. So in this case, U2 ends up as 320 plus that 128. And so U2 ends up as 320 plus this 128, 448. And a lot of people from here, once they identify U2 and U1, simply do the 448 minus the 320, boom, they're good to go. But careful, all of this is in weeks. And so this term, this U1, is for the total distance that he swam. And so this is the distance that he swam. How many times per week? Twice. So you gotta divide by 2. And he swam to the marker once and then back to shore. You gotta divide by 2 again. So dividing this U1 twice by 2, once by 2 because it happens, 2 times per week, and divide by 2 again because he swims there and back, is what gives you the distance to the marker. And so as we mentioned earlier, for U1 it's to the markers 80, not kilometers, 80 meters, yeah? And doing the same exercise for U2, you can see that the distance to the marker is, well, you gotta divide by 2 twice. See, again, the intuition is this 448 is the total distance on the second week, but the total distance was earned because Felix swam 2 days, but also went there and back twice. So that means that the distance to marker is 112. And so the distance sort of for part triple I, it says calculate the distance between the marker and the shore in the second week. It's going to be 112. And so over here, if we check the answer key, we see that for part D triple I, you reach that 112. An intuitive approach we can try to do, for me at least, this is method 2, which is divide by 2, divide by 2. And so that is how we would do part D triple I. Last but not least, for part E, we need to calculate the distance of Felix's final swim in his 12th week of training. And so notice when it says final swim, it's not talking about the final week, it's talking about the final swim. And recall that there are 2 swims per week. So first, let's find it in terms of weeks. So the final swim is on the 12th week. So you basically, for part E, and let me put it in a different color so that it stands out from the rest. Basically for part E, you need to find U12. And so for finding U12, we can use this equation here. So U12 equals U1 plus N, which is already implied is 12, minus 1 plus D. So plugging all of that in, you end up with U12 equals U1, which is 320. Then you have this 12 here, minus 1. Epa, wait. Give me a second. Is there a plus here? I think I'm trolling. There's a times. There's a times here. My bad, guys. It's a big multiplying, not a adding. Yeah, so U12 equals this U1, this 320, plus 11D, because this is multiplying, my bad. Oh, and we know that D is 128 from earlier. So U12 equals all of that. See, so it ends up as 320 plus 11 times 128. And the big brain play here is that this is how much Felix swam on the last week. So on the last week, our good old friend Felix swam 1,728 meters. Wow, that is crazy. So basically that means that on the first day, he swam 864 meters. And on the second day, he also swam 864 meters. And I reached this because I divided by 2. And so notice, Felix swam this amount on the last week, but because per week Felix swims 2 times, You divide this by 2, and so this was the second to last swimming session, and this over here was the last swimming session. So for part E, it would end up as 864, which is exactly what we see right here. So again, there's 3 methods, which is impressive, but all of these reach the same 864 that we see there. Notice how, again, there's a method point, which is just attempting stuff. See? So even if you're not sure, just attempting to solve can get you points. And it's important that your starting point will be stuff from the formula booklet, from the graphing calculator, almost always. And so that method point should be easy to attain. And I strongly suggest that you think of exercises or think in your studying in terms of which methods do I have at hand, which formulas do I have at hand. Those are the ones you really have to manage and master. Anyways, definitely enough talking by me. That would be for number 3. Alright guys, for number 4, this is a classic example of an exercise that looks really scary, but I don't think it's that hard. I think most people get scared of this exercise because you have a 3D sort of diagram, which is not too exciting, we'll be honest. But once you get the hang of it, of how it works, it's not that crazy. See, so the main challenge here, for me at least, is understanding how to handle 3D sort of coordinates, okay? And I've come to realize that lately the IB likes to put in their tests at least one of these exercises. See, I wouldn't say that it's always because I don't see it as super duper common yet, but I do see it gaining more traction, and I think it is something that the IB will be asking more frequently. Así que we have that Airflow Industries is designing a doorstop in the shape of a triangular prism. That's the first thing that they tell us. What the heck is a triangular prism? Yeah, for me, and this is extremely intuitive. If you ask your teacher, he's probably going to disagree. But for me, the most intuitive sort of definition is that a prism is going to be a shape formed by the extension of another. And so if you take this triangle and extend it, you're going to end up with a prism. So for example, you draw this triangle here and you say, you know what, I'm going to extend it over there. And so if you extend it over there, that means that you end up with a bunch of more triangles. ¿Cierto? And so if you end up with a bunch of more triangles, it starts looking like this, like this, like this. And eventually you might end up with a shape. After you fill it in with a bunch of triangles, you end up with a shape that looks a little bit like this. Boom, not bad for art, eh? And so eventually, because you extended that face of the triangle outwards, you end up with a shape, and that shape will be triangular prism. ¿Cierto? So you could do like any sort of prism. You just take the triangle and you throw it out there. ¿Cierto? You extend it, etc. So in this context, you can sort of think about it as ABC, starting as a simple triangle, and then you extend it this way. So you draw millions of triangles until you will form this shape. That is a triangular prism. See? Why is that useful? It's useful because you can understand that all these shapes are sort of like equal to each other. There isn't anything like slanted here a little bit. No, it's just the triangle here is the same as the triangle there, which also helps you understand that, for example, these are the same height, these are at the same height, these are at the same height. Like all that kind of stuff happens because it's a triangular prism. Enough talking, let's jump a little bit more into the exercise. They give us the points A, B, and C, which are these guys here, that are exactly on one of the triangular faces of the prism. So ABC forms that triangle here. And then they tell us a little bit randomly, although the AB never gives you something randomly. It's always useful. They give you point D, which is way up here on the other end of the prism. Blah, 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 blah. All measurements are in centimeters. Let's include that in our answers. And so for part A, you need to find the coordinates of F, which is this guy here. Así que, as I mentioned earlier, the big challenge here is understanding how to manage a X, Y, Z plane, coordinate, whatever. All right? So let's first understand that we come from the land of X and Y. See? And so when we come from the land of X with Y, okay, any point that we write down, we express it as X, comma Y. Makes sense, ¿cierto? And in order to pass on to this Z or 3D sort of diagram, or I don't know what word to use, plane or whatever, notice how your X and Y are sort of like the face on the ground. Okay, so now X and Y tend to be, or I like to think about it as like your like horizontal, I mean, I wouldn't say horizontal, but think about it as like your floor. So X and Y is your floor. Well, Z is now going to be your height. And so that is intuition that I can share here. Z is going to be your height. X and Y is going to be like the stuff that's flat. And so to pass from this to this, you basically take this guy, throw it flat on the ground, and then pop a Z that goes all the way up. See? That's all that's really happening. Why is this useful to know? It's useful to know because we pass from X comma Y onto this here, which is X comma Y comma Z. As you can notice, we pass from X comma Y to X comma Y comma Z, and this actually helps you to find the coordinates of F. See? How the heck does it help you find the coordinates of F? Well, it helps you find the coordinates of F because F is aligned with A. And so if F is aligned with A, well, what values does F share with A? A, how you doing? A is on 13, comma 1, comma 0. Ahora, because we're talking about X, Y, and Z, we're saying that for A, X is 13, so that would be this 13 here, and that Y is 1, which is this 1 that's here, and then the Z, which is the height, is going to be 0. So no height. On X, you go 13. On Y, you go 1. And so what can we apply that to F? Well, because F is, on the same sort of, I don't really know how to call it, but it's on the same Y as A, ¿cierto? They're both the tippy tops, ¿cierto? That means that F, for sure, is going to have an X value that you still don't know because we still don't discover what this is, ¿cierto? So the X value is something that we still do not know, but you know for a fact, because it's so similar to A, that it has a 1 for Y, which is this one here, and a 0 for Z. And so that's the first thing we can establish. Because it's a triangular prism and A and F are both the tippy tops, you can sort of share these two values between A and F, for sure. But the X value, the one in red, you still don't discover it. Así que ojo, how do you discover the X value that's in red? Well, this X value that's in red is assigned to F, and F is on the same X value, so on that same X line as our good old friend E, and also our good old friend D. And so D shares the same X value as E, it just doesn't share the height. But it's still along the same X value, ¿cierto? So that's what matters here. D is still in the same X value as E and same as F. Así que D, we know, is, from the context of the problem, 4, 25, 7. And so you know that its X value is 4, so that means that this guy is 4. So that means that over here we can leave F as 4, 1, 0. And if we check our good old friend, the answer key, we can find that effectively we have 4, 1, 0. See, so the big challenge is really just being able to read 3D graphs. Okay, so that is for part A. A little bit of a longer explanation, but I think it was worth going piece by piece. For part B, we have find AC. Ahora, when they say it like this, find AC just like that, it's basically telling you to find the distance. Some of you might be thinking, this guy, he's making it up. How does he know it's talking about distance? Well, because if it would say something like A, B, C with a little hat, the little hat is telling you that it's angle. And it's actually telling you, oh yeah, find the angle B that is between A and C. But because they didn't put the little hat or anything like that, you can sort of assume that it's talking about distance. I've also seen it like this, find AC with a line on top. And if it's with a line, it's definitely distance. But if they say just like this, it's going to be distance. See, so the moment you're thinking about distance is the moment that you're also thinking about this thing called the distance formula. And that also leads you to the formula booklet, and it will be the 2 easiest points of your life. Ahora, this right here, I talk about it a lot. This is extremely important for us to understand. It might be simple. It might just be a video explaining how to find and use the distance formula. But the methodology here is huge. What I need you to have in your toolkit is a step that is in the middle. And so you need to understand what tools you have available. And so the moment you understand this key concept distance, you jump into your toolkit and say, okay, what do I know about distance? And you know that there's a distance formula, and you know that it's in the formula booklet. And so what I usually say is that if you master or really, really understand everything in the formula booklet, it will be easier for you to identify which tools to use after you catch on to it, what is the key concept or core concept that they're asking for. Así que, in summary, you realize they're talking about distance. The word distance makes you think of distance formula, and you know that the distance formula is in your formula booklet. That is a sort of thought process that I need, and this works for trigonometry as well. You realize you're talking about trigonometry exercise, you know how you have the sine rule and cosine rule, you jump to the formula booklet. That is the sort of approach I would like to suggest. And why do I talk about the formula booklet so much? Well, I talk about it so much because it's going to save you the day of the test. The day of the test, ladies and gentlemen, you can enter the test with the formula booklet. It is a tool you can use the day of the test. As you can master it, love it, it's going to save you that day. And so here is the distance formula that we can apply. And notice, some of you are probably thinking, why would I have to master the formula booklet? It's just a bunch of formulas. I can look at them when I'm there, the day of the test. Pero ojo, the day of the test, you're not going to have a lot of time, and it's important to have the speed and be able to identify the tools you have available. And so that is why I suggest to master the formula booklet. That's like if I ask you to, I don't know what would be like a good example. It's like, I don't know, you have to like, I give you the task of like chopping down a tree. Well, you got to master your axe, how to sharpen it, how it works, this or that. You need to practice with the axe, and then the day that you cut down the tree, you already practiced with the axe, so you're good to go. Don't fall into the trap of saying, I'm going to have an axe, it's going to be fine. Dude, one thing is having it, the other thing is knowing how to use it. See? Así que, formula booklet, practice with it, love it, learn it, it will save you. Yeah, so distance formula is this here. So I'm just going to write that over there for a second. So distance equals, here's a little bit more space, distance equals square root of x1 minus x2 squared, I think, ¿cierto? Plus y1, sorry, minus y2, also squared. And so all that's happening here is that they're asking you to plug in one point called x1, y1, and another point called x2, y2. Alright, some of you are already pointing out, oh, this guy messed up because we are talking about xyz, not about xy, and I say, you are correct. So let me search my formula booklet again, and there we go. Here we have for between 2 points with a z as well, ¿cierto? See, a good thing I realized it can happen to anyone. It's just going to sort of extend our formula a little bit, as long as I can tell, claro. And here at the very end, we're going to put the z values as well, see? So all we have to do from here is establish what is my first point. That's why they have the little ones, ¿cierto? And what is my second point. So as long as you're consistent with that, with defining your first and your second, you're good to go. We will be defining our first as a. So a is going to be 13, 0. And our c, which is our second point, is going to be 13, 25, 7. 13, 25, 7. So if I plug all of that in, the only way you can really mess up is by plugging it in correctly. So I even suggest writing down just above what each thing is. So this is x1, this is y1, this is z1, this is x2, this is y2, this is z2. So this is just a 30-second step of having very clear what is x1, what is x2, what is y1, what is y2, etc. So plugging in now, you end up with something like square root. Let's actually just do it on the calculator right away. We have square root of 13 minus 13, so that's a little bit troll, but let's just plug it in, plus 1 minus 25. Opa, I forgot the parentheses. 1 minus 25 squared plus 0 minus 7 squared. So this, let's agree, does not look particularly pretty, but we did follow the process, and that's what matters. You end up with 25. So you get distance of AC equals 25. Let's leave it in centimeters because those are my units. So AC ends up as 25 centimeters. And then we check over here. Notice one of the points is literally using the distance formula, and you end up with AC equals 25 centimeters. Yeah, excellent. And so from there, we can now jump onto part C that says, show that. That's important information. Show that, show that triangle ABC is a right angle triangle. And so now, when you face a show that exercise, it's important to understand that if they tell you show that this, well then this is true. Why is this useful? Because if you know that this is true, that means you can try to solve part D knowing that part C is true, which sometimes is actually very necessary. And so that's just a quick sort of test taking strategy. In my experience, show that exercises are pretty hard as well. This one is a little more friendly, but in general, they're pretty hard. And yeah, so that's the thing with show that exercises. In this case, because we're talking about a right angled triangle, well, I have to dig into my tools of what are my tools for right angles. And so my tools for right angles, you should be thinking of two things. The first one is the SOHCAHTOA of trigonometry. SOHCAHTOA is only for right angle triangles, not all triangles. And you also have a Pythagorean theorem, which by now, if you're not sure what Pythagorean theorem is, good luck on the day of the test. So that is our tools for right angle triangles. So I can apply either, and if either works, and I can check that it works, well, it's a right angle triangle. In this case, it's a lot friendlier to use the Pythagorean theorem. A quick summary for anyone that is still not sure what the Pythagorean theorem is. I'm just teasing, by the way, we all forget what it is once in a while. Pythagorean theorem is for any right angle triangle. You have the fact that a squared plus b squared equals c squared, but only on right angle triangles. And what is the only thing you have to be super aware of? That c, the one that's alone on the other side of the equal sign, is your hypotenuse. How do you identify the hypotenuse? It's the long section. It's what is on the opposite of the 90 degrees. That's basically all you have to have super duper clear. And so for showing that ABC is a right angle triangle, well, you can identify this triangle here. A, B, C. And so the long section is AC, ¿cierto? So let me actually draw that out for a second. If I draw that angle out, that triangle out, we have B, point B being here, ¿cierto? We have point C being here. You have point A being there. And from part B, you identify that this distance here is 25. And so if I discover these two other distances from B to A and from B to C, I should be good to go, ¿cierto? So let's start with from B to A. From B to A, it's, well, this distance here, makes sense, ¿cierto? And this distance here, as you can see, point A is 13,1,0, and point B is 13,25,0. And so they share the 13s, which makes sense because they're on the same X sort of value. And the Y values are a little bit different. So here you have 1 for A, and you have 25 for B. And so between 25 and 1, you have 24. So this same sort of distance of 24 is the distance of 24 that's happening there. As you get from B to C, from B to A, you end up with 24. And now to find the distance between B and C, which is this height here, ¿cierto? Let's just write down the values of C. C is 13,25,7. And immediately we can tell that they share these two 13s because they share this 13 here for the X value. They share these two 25s because they share the Y value here. ¿Cierto? They both have the same y value for B and C, but they don't share the 7 and the 0, so that means that from here to here, here you have 0, here you have 7. Well, the difference is obviously going to be 7. So that is how we sort of filled in our triangle of ABC. And so in order to prove if this is the right angle triangle, well, this has to be true. And for this has to be true, well, let's figure it out. And so if it's true, that means that 7 squared plus 24 squared equals 25 squared. Así que veamos. So 7 squared plus 24 squared gives you 625. And 25 squared gives you 625. And so because 625 equals 625, then this, happened. And if it happened, it has to be a right angled triangle. So that is how we showed that triangle ABC is a right angled triangle. And method 1 is suggesting going for 24 and 7 and using the Pythagorean theorem. So you get bada bam, bada boom. The other method is a little more like it has to do with entering into AB and BC being parallel and stuff like that and blah, 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 and perpendicular. It's a little more creative. For me, I would just stick to the Pythagorean theorem. So that would be for part C. And then part D, we have find the volume of material needed to make the door stop. And part D is worth 3 points because it's challenging you a lot to understand the concept of a triangular prism. So remember how at the start I mentioned that to form a triangular prism, you draw a triangle and then you sort of take it and extend it to the side. The moment that you take it and extend it to the side, it means that you drew a bunch of other triangles that sort of go along with it, ¿cierto? And you drew so many triangles in between that you actually ended up creating another shape, ¿cierto? And so because all these other triangles sort of showed up or whatever, you literally end up with a new shape. And that shape is going to be your famous prism. And so as you can tell, you're basically taking this triangle and dragging it outwards, and that gives you your new shape. Why is this useful for understanding volume? Well, because volume is basically that. It's just the area of one triangle. Yojo, listen carefully how I'm going to say it. Volume is just the area of one triangle or one face pulled to the side how many times it has to be. And so basically volume is just going to be finding this triangle that we drew in green. How many times are we replicating the triangle to the side? That will be our volume. And so I wonder if there's a formula booklet for this. Maybe there is. Mira, it's even here. So volume of prism is going to be AH, where A is the area of the cross section. So in this case, we're talking about a triangle, and H is going to be the height. See, that's a little bit weird though, because the height here is what we're describing as this going to the side, ¿cierto? So I'd rather think about it as taking this triangle in green and how many times to the side do you sort of pull it, ¿cierto? And so the area of the triangle in green, I'm gonna make a little bit of space here for part D. Actually, no, we're gonna do it here. So the area of the triangle, is, well, it's base times height divided by 2. And so the area of that triangle, because we've been working with it a lot, is 24 and 7 is the height. As you get 24 times 7 divided by 2 gives you 24 times 7 divided by 2, not that, 84. So the area of the triangle is 84. And so this area of 84, well, how many times do you pull it to the side? You pull it to the side whatever distance from here to here is, quite literally. So from here to here is how many times you are pulling it to the side. Makes sense. How many times is that? Well, you have 13 for A, 4 for F. Let's recall that I'm talking about these 2 points. So 13 for A, 4 for F. So the distance from that to that is going to be 13 minus 4. 13 menos 4 gives us 9. Así que for the area of that prism, we end up doing 84 times 9. And that is basically what we're doing for volume of prism. We're saying that the volume of the triangle is 84, and you're pulling it to the side 9 times. So that means that 84 times 9 gives you 756 centimeters cubed. Cubed because it's volume. If you have something cubed, it's going to be volume. If you have something squared, it's going to be area. And if you have something to the power of 1 or just nothing at all, it's going to be distance. All right, so that is for part D, 756. Thank you very much. Now we jump onto this second sort of section, ¿cierto? So this second sort of section, they tell us that to lower the cost of the doorstop because airflow is incredibly capitalistic, they decide to reduce its volume to 625. This is very important because the first time I read this exercise, I actually subtly missed it. It says that airflow decides to reduce the volume of the doorstop to 625. So they reduced it to 625. At first I thought it said by 625. No, it's saying to 625. So the volume of this new sort of doorstop is 625. And how did they reduce it? By removing the shaded section shown in the diagram. So they removed this whole sort of cube here. Not exactly a cube, but this sort of shape. They removed it. And so the doorstop is now only this part. Okay, that's what it's sort of trying to tell you. So that is my new doorstop. You get rid of the shaded section. And thankfully, the remaining triangle faces are still right angle triangles. So you still have a bunch of right angles over here. That might be useful later. For the length of the doorstop, for the length of the doorstop, AX, they tell us that it can be calculated by AX equals AB times square root of VS divided by V0. And they tell us that VS is the volume of the smaller doorstop, while VO is the volume of the original. And through all of this, you need to find AX. Most of us here start freaking out, but you need to go piece by piece. How much of this do you know? Try to fill in one thing at a time. So for finding AX, you need to discover what is AB. You need to discover what is VS and what is VO. So AB is this original distance, which over here is this guy here, is this 24. Quite literally. And so AB you can immediately say is 24. VS is the volume of the smaller doorstop. And earlier they told you that airflow decides to reduce its volume to 625. And so the volume of this new doorstop, of the smaller doorstop, is 625. And the volume of the original, the volume of the original, you found it over here, 756. And so notice how suddenly this function that looked extremely nasty and scary, you go piece by piece and realize, oh yeah, you actually have everything you need. This partly happens because part E, this doesn't always occur, but it can be like a hint to move forward. Part E usually has something to do with part D, part C, something from earlier. See, in fact, notice that for part C, for showing that this thing was a right angle triangle, we used something from part B. And for part D, for finding the volume, well, we first needed to find the area of this triangle. And it helped us a lot to know that this is a right angle triangle. And so those are the sort of little hints and tips and this and that can help us along the way. Part E was particularly easy because we just had to fill in this function, which comes from a bunch of stuff we did earlier anyways. Yeah, if we fill this in, you end up with AB being 24 times the square root of this fraction. And so to express a fraction, I'm going to go alpha y equals press on the first one. Here we can put VS, which is 625, and then VO, which is 756. So we pop enter, and it gives us 28.821. 28.821. 789. And so for finding AX, you can pretty much just leave it like this. It will be in centimeters, ¿cierto? And just like that, because it's a distance, AX is a distance. If you want to leave it as significant figures, you count 1 to 1. Do you round it up or keep it the same? You keep it the same. So you can leave it as 21.8 centimeters if you'd like. Over here, we can see that that is exactly what's happening. So notice, part E is correct substitution using their AB from part C or D. And this, ladies and gentlemen, I did want to mention as well. The IB usually gives a lot of credit and points for following the right procedure. That's also why I talk so much about procedure. So in this case, you get the right answer for plugging in what you got for AB. And so even if you plug in the wrong AB, you still get a point. That is how important procedure is. You can plug in a negative value that makes no sense. But right here, according to this formula or to this mark scheme, you should get 1 point. And so you follow the procedure. The more you follow the procedure, the more you write down which formulas you're using, the more sort of points you're going to get. See? So look, just using the distance formula gives you a point, etc., etc. See? Yeah, so that is for part E. And this last part is a little tricky because it has a lot of text. Pero we'll go about it together. We have that the material needed to make the doorstop costs $0.025 per cubic centimeter. So per cubic centimeter, it costs us $0.025. And they tell us that the production of each doorstep requires 10% more material than its final volume due to wastage in the production process. And this right here, intuitively think about it as like, I don't know, you're trying to create like a door from a big block of wood. You know, you don't have the exact amount of wood for the door. You have a little bit of extra wood because you have to shape the door. And so that is the extra 10%. That's basically what they're trying to tell you here. Así que to make a profit, the company will sell the doorstep for 20% more than the cost of the material. So this new doorstop, so notice here it says new doorstop. They ask you to determine the price to 2 decimal places of this new doorstop. What is the volume of the new doorstop? The volume of the new doorstop of VS, the smaller doorstop, is 625, which is the same 625 we saw here. So the volume is 625, right? So let's start with that, yeah? The price of this guy is going to be 20% more than the cost of the material. So the question here is, what is the cost of my material? The cost of my material is going to be, it costs 0.025 per cubic centimeter. So this is the first thing you might sort of think, yeah, so you take your volume and you multiply by 0.025. So per cubic centimeter, it costs 0.025. So in that sense, we're good. But careful, the production of each doorstep requires 10% more material than its final volume. So although my final volume is 625, I do have to multiply this by 1.1. So here I'm going to put a parentheses, which, multiplying wise doesn't change anything. But for our mindset, we will think about it as like, this is my final volume and it has to be 10% more. And so this is basically how much volume you end up needing. And per cubic centimeter, it will cost me 0.025. And so that is like the first sort of big step. This is the cost of my material, ¿cierto? So this is my original volume, which has to be 10% more. And how much does it cost? It costs 0.025 per cubic centimeter. So that is like the stage I'm at. And all of this, we will be selling it at 20% more than the cost of the material. So because all of this is the cost of material, now I just have to multiply by 20% more, which would be 1.2. That is the sort of logic that's happening behind it. Some of you might be thinking, well, if it's 20% more, why didn't he put 0.2? Isn't that 20%? And I would say yes, but careful. If you take something like 500 and you multiply it by let's take 100 and you multiply it by 0.2, you end up with a smaller number. So whenever you multiply by something less than 1, it ends up being smaller. And so 100 times 0.2 gives you 20. You end up with a smaller number. So essentially how I would like to think about it is that you're going to take that 100, multiply it by 1 plus whatever you're trying to do. So if they tell you that it increases in 20%, it's going to be 1 plus 0.20. So there's the 20%. Or if they tell you that it reduces in 20%, you're going to do 1 minus that 20%. Which actually the in-between step is that it ends up as, well, that 1 minus 0.2 gives you 0.8. See, and so I always suggest that you sort of think about it as starting from the 1. See, and so if I were actually to do this again, starting from the 1, you'd have the 625, which will be increasing by 10%. So you're going to do 1 plus 0.1. That's a very nasty one. Let me try again. Yeah. And this is going to be 0.025 per cubic volume, ¿cierto? And all of this is the cost of my material, which I will have to multiply by 20% more. And for 20% more, it's going to be 1 plus 0.2. See, and so that's just a very, very rigorous approach for making sure we are doing 20% more and not 80% less or whatever. Anyways, you pop all of that into your calculator. So you do, I'm going to do this part here, the one up top. You end up with 625 times 1.1. So that's telling you the final volume has to be 10% more because of the wastage in the process. And this per cubic centimeter will cost me 0.025. And all of this has to be 20% more. Because it's all multiplying, the order doesn't really, I mean, the parentheses don't really matter. That's just for thinking about the exercise. You end up with the price being 20.625 because you're talking about 2 decimal places. You count 1 and 2, you round it up or keep it the same. You round it up, so you would leave it at 0.63 USD, 20.63 USD. So you can notice, just trying to multiply here gives you a method point. Getting the right answer is the second part. But a big portion of your points in this entire test is just method, using the right formula. And so master the formula booklet. Have very clear which tools you have at your disposal. Identify the concepts, and through that, figure out the procedure. Don't jump straight into it and write stuff. Just think first, what world am I in? What concepts am I going for? And through that, use the appropriate procedure or method or formula or whatever. Yeah, guys, enough talking by me for today. That is for number 4. All right, guys, number 5 is quite simply super hard. It's a Voronoi diagram. Voronoi diagram show up once per test. I mean, like, it either shows up in paper 1 or in paper 2. So if you were doing the test of this year, which is paper 2, and you take the test of paper 1 and there is no Voronoi diagram, then prepare a Voronoi diagram because it will appear on paper 2. Yeah. That being said, we have that the locations of 3 fire stations within a 50 by 50 kilometer rural area of Japan are shown on the following map. And so they tell us that a Voronoi diagram can be used to determine the part of the rural area for which each fire station is responsible. The Voronoi diagram for the 3 fire stations is shown on the coordinate grid beside the map, where 1 unit represents 2.5 kilometers. All right, so before we jump into part A, B, C, D, etc., let's first understand the Voronoi diagram, how it works, how it is born. Okay, the useful thing about Voronoi diagrams and why they exist in the first place is because they are great at helping you define, or they're great for like doing like city planning or what's closer to this, closer to that, etc. Yeah, so if you take these 3 points, which I think we call them sites, and you apply like the Voronoi diagram logic, basically what you're trying to do is split this up into sections so that we define who is assigned to each section. So for example, right now, all of this belongs to B. And so any point in that area belongs to B. Ahora, why does it belong to B? It belongs to B because all these points in pink are closest to B. The moment you pass over here, for example, you are now much closer to C than to B. Even way up here, this point in orange is closer to C than it is to B. And so all that thing in all that thing in pink belongs to B. All this thing in orange belongs to C. And all this thing in red belongs to A because it is closest to A. So that's the first intuition we have to sort of understand about the Voronoi diagram. The second thing we have to understand is, well, those areas that I just defined came to life because of these lines here. Now, what the heck are these lines here? These lines here are basically, if you think about it a little more intuitively, okay, they are going to be what we call the perpendicular bisectors. And I'm going to talk a little bit about this concept because I haven't even looked at the exercise, but I just know it's going to show up. So what the heck is a perpendicular bisector? Well, something that's perpendicular is, for example, two lines that cross like this and form a 90-degree angle. So all of this would be a case where we have something that's perpendicular, and something that is a bisector, by this, by that, bisexual, it is cutting into two. And so sect is going to be like scissors, it cuts, ¿cierto? And bi is that it cuts it into two. So why is this relevant? Because if you draw a line from B to A, it is exactly by creating a bunch of perpendicular bisectors. So for example, this one here, that cuts in half the one that's in red. And then maybe between C and B now, you do yet another perpendicular bisector, which would be something that goes like that. And then between and then between C and A, well, its perpendicular bisector would be something that goes like that. You can suddenly notice that all these perpendicular bisectors are exactly what helped you create the Voronoi diagram. Out of course, by logic, you end up forming a Voronoi diagram that uses the perpendicular bisector up to here, and then up to here, and then up to here. But as you can see, the three lines in black are all perfectly aligned with the perpendicular bisectors that occur between B, A, and C. And so that is the sort of like method in order to establish or create the Voronoi diagram. And it is also implicitly by a bunch of math rules that I don't know too well, but intuitively, this is what helps you have the closest points per site. This is what helps you define the regions, the stuff we drew earlier in pink, orange, and red. See? And so through these perpendicular bisectors, it's that you are able to identify the correct sort of areas and regions and sites and lines and stuff in order to create the Voronoi diagram. See? So for part AI, the first thing they ask us to do is to find the midpoint of BC. All right? So midpoint, well, it's going to be the middle of a point between B and C. And so BC is, because of what I established earlier, so because of what I established earlier, BC is actually going to be right there. It's going to be right on the perpendicular bisector. So that's the first thing that we can already realize why knowing about the perpendicular bisectors is so important. See? So right, that point is on the perpendicular bisector between C and B. Okay? And for identifying a midpoint, well, the moment you read the word midpoint, you should be thinking of the midpoint formula. And this should already be leading you to the formula booklet. Formula booklet with my wonderful, wonderful handwriting. It's called cursive. Get used to it. So you read the word midpoint, you think of the midpoint formula, you go to the formula booklet. That is the level you need to reach. The formula booklet will save you the day of the test. Might as well get to know it well. And so the coordinates for a midpoint, the formula is right here. See, so I'm going to just write that down real quick. So here we can have that. So I'm going to just write midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And so as you can see, this ends up giving you a sort of like x comma y that depends on what you define as x1, x2, y1, y2. What the heck is x1, y1, x2, y2? Is just two separate sets of points. So the first point will be x1 with y1, makes sense. And the second point will be x2 with y2. So in this context, because we're talking about the midpoint of BC, we're going to define x1 as B. So that means that this is x1, and that this is y1, and that this is x2, and that this is y2. And so if we define those things as x1, y1, x2, y2, plugging in here, you end up with your midpoint being 16 as x1 plus 8 as x2 divided by 2, comma 12 as y1 plus 13 as y2 divided by 2. So that means you end up with 24, if I'm not mistaken, divided by 2, comma 25 divided by 2. Let me think about that for a second. Okay, I think that looks fine. So here you end up with 12, comma 12.5. And if we check over here, we can see that it looks just about right. So 12, 12.5, and get a 1 point is just attempting the midpoint formula. This is why it's so important to have clear identifying key concepts and attempting a formula, because attempting a formula is already enough to get you a method point. So notice, just attempting to substitute into the midpoint formula already nets you a point for method. Yeah, that's why I talk so much about method, and also in general sticking to a formal booklet. Not every single exercise will have or the formula booklet will save you, but I would say that like 70% of the test is just handling the formula booklet. Yeah, anyways, so the midpoint ends up being for part AI ends up being 12, 12.5. So that would be for part AI. For part AI, we have find the gradient, so that's already a big word, of the perpendicular bisector of BC. And so this, ladies and gentlemen, is why understanding the perpendicular bisector is so important. Any Voronoi diagram will challenge you to understand the perpendicular bisector. And so that is why it's crucial to understand that the perpendicular bisector of BC is not the line in red, but rather this line that cuts like this. And how do you know it's the line in blue, not the one in red? Well, because it is perpendicular to the one that's in red, and it's bisecting it. It's cutting it in half. All right, well, the other way to understand it is that BC, well, is the line in red. And so you sort of draw the line in red, ¿cierto? So BC is the line that we have in red. And so it's going to be whatever is perpendicular to that and also bisects that. So the gradient of this thing in blue, okay, well, let's first talk about gradient. Gradient, you might have also heard it as slope, and slope in this case, okay, is going to be, if we go to the formula booklet, we once again have something for gradient. And so gradient is going to be m equals y2 minus y1 divided by x2 minus x1. Ahora, the point that we discovered is 12, 12.5. So that is the point that's in pink. See? If I were to discover another point alongside the blue line, I would be able to apply the gradient formula. But doing that is a little bit hard. ¿Cierto? I mean, I would have to find another point in pink. I guess I could sort of assume that there's one at 13,20. Like there might be one there, but it's not 100% certain. And so the most rigorous approach is actually sticking to the part of our definition of perpendicular for the bisector. And so what the heck does perpendicular mean? Earlier I told you that perpendicular means that you have 90 degrees angles all alongside it, which is true, but more importantly, you have to understand how these two lines that we're drawing relate in terms of slope. So if these are perpendicular, yes, there are 90 degrees, but it also implies the math rule that you have that the slope of the first one times the slope of the second one gives you -1. Now this is a big brain math play. It's not in the form of booklet, so you do have to know it. And you might have seen it in class as something that they tell you like, oh, if the slope of 1 is 1/2, then its perpendicular slope is going to be -2. And how did you reach that? Well, because you're going to first flip it, and then you're going to multiply by -1. So multiply by -1, see? At least that's how I learned it. Yeah, like you flip it and then you multiply by -1. How do you see that in this sort of mathy formula here? Well, you can rewrite m1 or leave m1 alone, so you end up with m1 equals -1 divided by m2. And so there, when you have the m2 below, you see that you're flipping it, and the -1 is going to be multiplying m2. See, so there you have the two sort of effects happening, ¿cierto? But more importantly, I'd rather have you have the knowledge that if you're talking about perpendicular lines, you have that m1 times m2 equals -1. This is for perpendicular. And if you're talking about parallel, which is something else that can show up, parallel lines look a little bit like this. The cool thing about parallel lines, if anything, is that they never touch. And the reason that they never touch, actually, let's ask the crowd over here. My fellow audience, why do parallel lines never touch? It has to do with gradient. The reason they never touch is because they have the same slope. So parallel lines have that this first slope equals the second slope. See? That's literally it. That's the only reason parallel lines never touch. It's because they grow at the same rate. They have the same gradient. So that means that they will never, ever, ever be touching. Yeah. Entonces, for finding the slope of the perpendicular bisector, rather than trying to use the gradient formula, which is probably doable, but a little bit harder in this case, it's a lot more accessible if we first find the gradient of our red line and then apply its perpendicular sort of like version. And so the gradient of the red line, so we're going to put a gradient of red, and using our formula here of y2 minus y1, x2 minus x1, we can define our y's as the same y's as before. So we have y2 minus y1, so it's going to be 13 minus 12, divided by x2 minus x1, so 8 minus 16. And this gives us 1 divided by negative 8, which is, well, same as negative 1 over 8. See, same thing. So if this is our is the gradient in red, well, its perpendicular version, which is the line in light blue, so the gradient of, this sort of like blue, is going to be flipping it. So you first flip it, so you put the 8 on top, the 1 on the bottom, and you multiply by negative 1. So it already has negative 1. You multiply again by a negative 1, and that gives you 8. How would you see it from here? You would see it from here by saying that m1 is negative 1 over 8, and m2 is what you're trying to find, and all of this equals negative 1. So m2, if you want to get it alone, you divide by negative 1 over 8. So you end up with negative 1 divided by negative 1 over 8, which looks at a little bit troll, but if you put it into the formula, into the calculator, you do end up with positive 8. So, bada bim, bada boom, the slope or the gradient of the perpendicular bisector of BC equals 8. Let's check over here, but it does look good to me. Again, just by attempting, you get a method point. Again, procedure, method, tools. That's the most important thing for maximizing the amount of points you can get. Part C says hence, and this is already important. If it says hence, it's telling you, oye, given from part II and I, solve III. Which is a huge hint, como, oye, use what you had from before to figure out this part. Hence, find the equation of the edge between sides B and C. Yeah, so there we have a little bit of Voronoi diagram sort of language. Sides are going to be A, B, and C. And then the edges between both is literally going to be, all the perpendicular bisectors that happen in between. So we need to find the equation of that edge between sides B and C. Basically, find the equation for the line in blue. And this is actually really easy, but you do have to have extremely clear your tools for creating a line. So we're going to write here, your tool for creating a line is the point slope formula. And the point slope formula is, it's actually right there. It's one of these three. So your equations for creating a line, you have three of them. You have y equals mx plus c, the classic. You have ax plus by plus d equals 0, which I think it was like standard form or something. And then you have y minus y1 equals m, parentheses, x minus x1, which is the point slope formula. So this is, I don't know the actual name, we're just going to call it the classic, the first one we learned. This one I think was standard, and this one is going to be point slope. Ladies and gentlemen, I know that you can technically start from any of these, and I know that there's ways to do that, but what I suggest for you is that you always start at point slope because it will always work. Starting from the classic is not always doable, or starting from the standard is not always doable, but starting from point slope is pretty much always doable. And from the point slope, you can travel to this, you can travel to that, etc. See? For the point slope, what you need is first a set of points, and secondly, the slope. So if you plug in x1, y1, and you plug in m, well, you're good to go. So in this case, our x1, y1 is going to be for a point along the edge between the sides and B and C, and this edge is the line in light blue. And so the point for the line in light blue is what we put earlier in pink, and what we have in pink is from part I, the midpoint. So this is the point in pink, and the slope of the thing in light blue is this guy here, this 8. So that's literally all you need. So for part 8 triple I, we're using the formula point slope, which is y minus y1 equals m parentheses x minus x1. In this case, our x1, y1 are these guys here, and our m is this 8. So you plug in y minus 12.5 equals 8 parentheses x minus 12, which ends up giving you y minus 12.5 equals 8x minus 12 times 8. I cannot brain right now, so I'm just gonna use our calculator, 96. And then we do plus 12.5 in order to get y alone. And you end up with y equals 8x minus, I know this is like a negative, but I'm just trying to think about it differently. Yeah, you end up as 83.5. So y equals 8x minus 83.5. So notice how you started on the point slope formula, and you ended up with your y equals mx plus c. And so very convenient, and there I showed you how you start from the point slope and reach the classic, and from here you can also reach the standard. I'm not going to show that because it's not relevant in this case, but we can see that it's doable. See? Yeah, so that would be for a triple I, and we can see over here that you can't even leave it in point slope form. There it's in point slope, but I'd rather have it as our classic standard sort of format. See? Either works. I stuck to that one. That would be for part A triple I. So that would be for part A. And now for part B, we have first, identify the fire station that is expected to respond based on the Voronoi diagram. If a fire is reported at a location with coordinates 14,10, justify your response. As you get careful with this, it says justify. When it says justify, you have to put a reason. So you have to consider a sort of reason in this case. 14,10, where does that land? Well, let's figure it out. So 14,10, we have the 14 here, and we have the 10 here. So 14,10 is right around there. Let me double check, 14,10, C. So the fire station that is expected to respond based on the Voronoi diagram is 14,10. 14,10, as you can see, is within the realm of B. And so because it's within the realm of B, site B is the one that should be reacting. Okay, and how do you then identify it's in the world of B? Because of the edges. So because of these two edges here, you can see that it's within the world of B. And so site B should be reacting. And so site B, because 14,10 is within the edges of site B. And then you can probably specify which edges, you know, between C and B and whatever. But that is probably good enough. Yeah, so it lines in the same cell, which is what I mean by region, right? It's closer to B than any other. You can give a bunch of different reasons, they all work. See? And for part B double I, it says suggest a reason why a different fire station might respond to this fire. And this is more of a context sort of question. See, so for part B double I, it gets a little more creative. This tends to happen in these longer exercises where you have like 1 or 2 points, usually just 1 point that you can earn by some context question. And so why would a different fire station respond to this fire instead of B? You can say something like maybe B is busy responding to a different fire, and so A or C has to come clutch and pull through, right? What else can you say? Maybe site B is under maintenance, and so site A or C has to react. Maybe the workers at site B are like on vacation. There's like a million reasons, so you just give one of them, and here you can see. So they could have responded to a different one. They don't have enough manpower. You know, there's a bunch of different reasons. Don't stress out too much on those. If it's literally a context question, it's worth 1 point. Don't lose too much time on that. See? That would be for part B. This is where it gets kind of crazy, because they tell us that a fire is reported at location D with these coordinates, which already look super duper nasty. And so with these coordinates at location D, the distance from D from A on the coordinate diagram to 6, oh my god, to 6 significant figures is that. And for part C, I need to show that the distance of D from B to 6 significant figures is also that amount. Wow, that is crazy. So let's first try to draw D. So D is at 11 and something and 7 and something. So 11 and something and also 7 and something. So 11 and something would be around here and 7 and something would be around here. It's probably landing right on that connection actually. So it's probably landing quite literally there. It's probably where it's landing. The thing on orange is what we're going to call point D. And so from here they're telling us that, or they ask us to show that the distance of D from B is also that amount. Okay? So the first thing is that because it says show that, this is true. And that might be relevant for part II or part DI or part DII. The nice thing about show that exercises is that they're telling you something that's true. They're just asking you to prove it. And so oftentimes part D needs something from earlier. Well, you can take this as a fact and work with it. See, so that's a quick test taking strategy that could help you if you're low on time. But for showing this, well, we encounter the word distance once again. And distance, we think of distance formula. And distance formula, ladies and gentlemen, I think we used it earlier. I think we used midpoint. I think on problem 4 we used distance formula. But anyways, distance formula, if we go over here, we find it aquí. As you get distance between 2 points is right there. So let me write it down around here. So distance equals square root of x1 minus x2 squared plus y1 minus y2 also squared. So as long as you plug in properly and correctly, you should be able to prove this appropriately. Because we're talking about the distance from D to B, well, let's first write down B and then D. We know that B is 16,12. So B is 16,12. And you know that D is this thing here. The 11 1/3, the 7 1/6. And just to plug in more easily, I'm going to convert this to decimals just for a second. ¿Cierto? So 11 1/3, you can literally do 11 plus 1/3 gives you 11.333. I'm going to put 3 with a hat to show that it's repeating. And then we can do 7 plus 1 divided by 6, que nos entrega 7.16 repeating, but it ends on a 7. All right, cool, thank you. And so if we write that down over here, we have 11.3 repeating, comma, 7.16 repeating, 7. I guess we could use the fraction to plug in more easily. I don't know, it depends on everyone. I'd rather use decimals. And so here we can establish that 16 is x1, 12 is y1, 11.3 repeating is x2, and 7.167 is y2. So plugging into our distance formula, we have that the square root of 16 minus 11.333333333 squared, so that's this first part, plus y1, which is 12, minus 7.16 repeating, that ends in 7, squared will give me the distance, which looks like that. So the distance we just obtained, that is terrible handwriting, I fully recognize it. Someone in the comments the other day told me, ugh, improve your handwriting, it sucks. This is cursive, deal with it. Oh God. Distance is 6.718548124. Let me double check. 6.7185488124. Thank you. Yeah. And they tell us show that to 6 significant figures that you get 6.71855. So the challenge here as well is understanding how significant figures work. Significant figures with a number like this, you're literally just going to go, 6 significant figures. So 6 figs. You're literally going to count 1, 2, 3, 4, 5, 6. This number, do you round it up or keep it the same? You round it up, so that means you end up with 6.71855. And this is just units. And as you can see, it's the same 6.71855 as over here. So that would be for part CI. And claro, just attempting to calculate the length of dB is essentially what we're going for here. And then for part CAA, we have show that any of the 3 fire stations would be expected to respond to the fire reported at D. So the first question we have to establish or answer is, well, why would any of the 3 be expected to respond? Well, because this point in orange, as you can see, is right in the intersection of all 3 perpendicular bisectors. Así que, if it is in the intersection of all 3 perpendicular bisectors, then all 3 are at an equal distance to be able to respond. Let's talk about that for a second, because it's very important to understand that from the Voronoi diagram, like knowledge or whatever. This perpendicular bisector here, if you stand ahí, right there, well, because it's on the edge between B and A, it's from equal distance to both. In fact, if you count the squares, it's equal distance to both. See? So and that will happen on any point along this line or this edge. See? And so anywhere along that edge, you will have an equal distance between B and A. If we do that on the thing that's in light blue, it will happen as well. If you stand, I don't know, on this point here, the distance from here to here is the same as the distance from here to here, same as this guy over there. It's just something that happens on the edges along the perpendicular bisectors. This one is a little more freaky, okay? But it would apply between C and A, okay? And so this point in orange, because it's between the 3 edges, between 3 perpendicular bisectors, this is actually equal distance from C to B to A. They are all the same distance quite literally. And so what you just proved, or what we have until now, they tell us that the distance from D to A is this 6.71. So you just figured out from D to A is 6.71. And what we solved right now is finding the distance between D and B. So between D and B, you also got 6.71. So all we have to prove now is that this last point is also going to be 6.71. So applying the distance formula one more time, but this time with regards to C, okay, with regards to CD, well, our approach is going to change just a little bit. Instead of having B that we're plugging in, we're going to be plugging C, and C is 8,13. And so just to do some quick maths, that means that over here, instead of plugging in the 16 of B, we're now going to be plugging in this 8. And instead of the 12, we're going to be plugging in this 13. So the approach is quite literally the same. Here we're going to erase, oh, god dang it. Let me go back. Yeah. So now we can understand that instead of plugging in this 16, we are going to be plugging in this 8. And instead of plugging in this 12, vamos a enchufar el 13. And so we press enter, and it gives you the same 6.7185, blah, 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 blah. And so for showing your work a little bit, you would basically write down the distance formula again, but just plugging in, or leaving clear that you're plugging in this and this. And then again, you reach this distance. And so all three are from the same distance. See, so that would be your way to show that, your way to prove. See? It's important that when it says show that you're proving something, so you have to give a reason. See, reasons are important in show that exercises. Your reason would be equal distances from D to everything. From D to A, from D to B, from D to C. All right, we're almost done with this great challenge of an exercise, but don't worry, we only have to deal with a section that is worth 7 points. So hold on to your horses because it's going to be a little tough. We have that the equation of the edge between fire stations AB is y equals 0.5x plus 1.5. So let's stop right there, talk about that for a second. This guy here is the edge between A and B. So they just gave you, let me erase all this stuff that's in like light green. They just gave you that the equation between A and B is this thing in blue, which is the y equals 0.5x plus 1.5. Then they tell you that the edge between fire stations A and C, which is the guy that I'm going to be putting in, do I have purple? We have purple, see. It's going to be, they don't give you everything. They tell you that has an x-intercept of 7.75. So this line here has that x-intercept. So that right there is 7.75, 0, because it's an x-intercept. That's why you have 0 for y. Okay, so you have like those three things, and let's actually try to express them over here. So the line in dark blue they told us was y equals 0.5x plus 15, I think. No, 15 makes no sense. Minus 15 plus 1.5, lol. Plus 1.5. Let me double check because I feel like I just got a little bit of brain rot. Y equals 0.5x plus 1. Yeah, perfect. And you know from earlier that the thing in light blue is, what is it? We got it earlier. It was this. Y equals x. So this guy is y equals x minus 83.5. So that is what we have up until now. And through all of this, for part DI, you need to determine the area. Oh my Lord, hang on to the steering wheel. Determine the area to the nearest square unit of the region within the given Voronoi diagram for which the fire station A is responsible. Wow. That is, no wonder it's worth 7 points. All right, let's do one thing at a time. So, region A. They gave you a bunch of different information, see? And they even gave you point D, all right? So now I'm thinking only about region A, ¿cierto? So region A is this thing on the bottom right, ¿cierto? And let's talk a little bit about everything they gave us and how it can be useful. See, this is definitely a little bit more creative. Point D, we know is this and this. So I'm actually gonna write that here. We know that point D is 11 with 1/3, comma, 7 with 1/6. 7 with 1/6. So that is point D. And through all of this, we have to find the area of A. What I suggest in this case, and this is a general sort of tip for any area exercise that gets a little bit hard, is that you start thinking about it in simpler shapes. Because if I ask you to find the area of this shape here, I mean, you're probably gonna get a little bit confused with what that shape is. I guess you could sort of argue that it's a kind of trapezoid and this and that, and you can probably sort of find something, but I'm not even sure like what it would be. ¿Cierto? It's tough. It's not easy. It's hard. See? And so what I suggest is that, okay, if you're trying to find the area of this entire thing, chop it up into reliable shapes. And so our reliable shapes is going to be one triangle here, which we will be calling shape 1. Then we have another triangle, which is like this. So this will be your shape 2. And then thankfully, because we applied 2 triangles here, 2 right angle triangles, we can apply a sort of rectangle or whatever ends up being as our shape number 3. So if you add up the areas of shape 1, 2, and 3, you end up with the area of the entire region. And that is a much more sort of friendly exercise to face, you know, than the alternative. See? So this is not going to be easy, but patience, my dear. Let's see what we can do. Let me make a little bit of space because my lord, we're going to need it. For this, wow, let me make a lot of space. Yeah. For shape 1, which looks like this. So for our shape 1, you know that right here, they gave you this, before that, you just drew a right angle triangle. See, because you drew a straight line from D downwards, ¿cierto? And so this is a right triangle here. This is a right triangle there. This is legit because you're talking about the edges of your diagram. So that's how you know that they're straight lines. See? So for finding the area of this first triangle, you have to do base times height divided by 2. That is the area of a triangle. Area of triangle, you have base times height divided by 2. Así que, well, what the heck is the base? What the heck is the height? Let's first talk about the base. And so what do you know about the stuff that's down here? What you know about the stuff that's down here is that this x-intercept is 7.75. And you know that this point in orange, the D, on x-axis is 11 1/3. And so this thing on purple is 7.75, and this thing on orange, which is the same x-axis, ¿cierto? The same x value, is 11 1/3. And so the base is going to be the difference between the 11 1/3 and the 7.75. Así que 11 plus that 1/3 minus the 7.75 gives you 3.58333333. So not exactly a nice number, okay? But it's a number nonetheless. And so following the logic, you did essentially, another way to explain it, okay, is that the 11 1/3 was this distance. The 7.75 was this distance. You subtracted both, you ended up with your base. That's basically what we just did. And so the base ends up as 3.58, 3 repeating. So now we have the base. How the heck do you have the height? Well, the height is just going to be how it jumps from this x-axis to the top, and it's jumping straight onto D, and the height of D is 716. And so this 716 is literally the height of your triangle. That one makes a little bit more sense. It's a little bit more intuitive. So the height is going to be 716. Yeah, we can write it as a decimal, I guess. So you can leave it as 7.16 repeating with a 7. See? And so the area of this first guy is going to be base times height divided by 2. So it's going to be the 3 point blah, 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 times the height, which is the 7.166. All of this divided by 2 nos entrega 12.840. I know these numbers look crazy, but stick to the procedure. See, stick to the procedure, stick to what you're doing. Use the entire numbers when multiplying. It's going to end up as nice numbers. These in-between steps are when you really have to just have faith in the procedure. Trust the process, trust the knowledge, trust the tools you have. See? Let's take it the area of this first one. So I'm going to write that down here. See? So the area of the first shape, which is this guy that goes like this, is 12.840 to 778. 7778. And how did you find that out? You found that out because this is 3.583. This is 90 degrees, and that this is 7.167. See, so this is just so that we recall a little bit what we did. The area of the second one, or actually before the second one, let's do the other triangle because it's the hard one, ¿cierto? So the area of the triangle that goes like this, so that, no, it is the second one, sorry. So the area of that triangle, see? So the area of that triangle, which goes like that, we're gonna discover it now, see? And so the first thing we're gonna do is establish what is our x value that travels along this, ¿cierto? So that x value, well, we see that the maximum is 20. We see that the thing in orange is 11 1/3. So if you do 20 minus the 11 1/3, you end up with what's in between. See, so again, you're doing 20 minus the 11 1/3, you end up with what's in between. See? Yeah. Control Z. So 20 minus 11 1/3 gives you that base. So you get 20 minus 11 plus that 1/3 gives you that base. I don't know if you guys can hear my cat, but she's suffering out there. She's emotionally dependent. 8.67 will be the base of this triangle. And the height of this triangle, again, will sort of depend a little bit on this height on D, ¿cierto? And so this height on D, which is the 716, ¿cierto? You have to compare it to this height here. And this height here depends on the function for the edge that they gave us. And so the function of the edge that they gave us, well, to figure out this point here, you know, is that x equals 20. So basically, you take this function here, and you plug in 20 into it. Ahora, let's understand what we're doing here. Right here, what you're saying is that, oye, on that edge between a and b, which is this function here, the y equals 0.5x plus 1.5, which did come from this, the edge between a and b, ¿cierto? On that edge between a and b, if x equals 20, which is what we just did by plugging in, what is my y? That is all you're doing, see? And so you plug in 20, you end up with y equals 0.5 times 20 gives you 10, plus 1.5, as you get y equals 11.5, see? So if y equals 11.5, and you have that the point in orange is 716, basically you're gonna do 11.5, so this height here, minus this height here, which is around there, ¿cierto? Will give you the height of our triangle. That's what's happening, see? Así que, let's do it. So 11.5 minus the 7 with the 1/6, sixth, gives you 4.33333. So the height over here is 4.333. You do base times height once again. So you do base, which is that 8.67, ¿cierto? 8.67 times height, which is the 4.333, divided by 2 gives us the area, which ends up being 18.77778. So 18.7 repeating, ending with an 8. So that is for the two triangles, which is definitely the harder part. And this last part is just going to be that sort of rectangle or square that we're seeing. See, we're still not sure if it's a rectangle or square. We're about to find out. If we go up here, this third shape, you actually partly already discovered this height, ¿cierto? Actually, you already have everything you need, see? You basically have to apply the height. Notice very carefully what we're gonna do, see? For this square or rectangle or whatever, all you have to do is multiply the height of the first one times the base of the second one. So there you end up with your length times width. It's the height of the first one times the base of the second. The height of the first one is this 7.167, and the base of the second one is the 8.67. And so if you do those two things, we can actually even go find them. So you have the 7.167 So this is the height, or you can do like length times width, however you want to think about it, times the 8.667, que aquí está, gives us the area 62.111112. Así que it gives you 62 point, a bunch of ones with a 2. So our areas of the three shapes are this guy, and this guy. And so if you, for finding the area of the entire region, you just have to sum up the three shapes. So the first shape times plus the second shape plus the third shape is going to be, well, exactly that. So it's going to be the first shape, which is a 12.840, plus the second shape, which is this 18, plus the third shape, which is the 62. So you're doing the first triangle plus the second triangle plus the square, gives you 93.7291. So 93.7291,668. So again, not nice numbers, but trust the process. Stick to the intuition of doing the first shape plus second shape plus third shape, and it's a much more bearable sort of exercise. They ask you to find it to the nearest square unit, and so nearest square unit would be without decimals. So you count 1, 2. Do you round it up or keep it the same? You would round it up. So you leave it as 94 units squared, and then we check over here. God almighty, please let it be correct. There you have the 94 square units. And so notice how one of the method is dividing into two triangles, which is exactly what we did. There was an approach with a trapezoid. I didn't really want to get into that, but clearly there was an approach. But the cool thing about both methods, and even the third method, is that, or even the fourth, this was our method, dividing into two triangles and a rectangle. The cool thing about all these methods, except for calculus, which gets crazy, is that you are taking your shape and dividing it into many. And that's a much nicer way to think about the exercise. See, so take your shape, divide it into many. It's much more bearable than, trying to tackle the entire thing at once. See, much like anything in life, take it piece by piece. It's much easier. Yep. And now, last but not least, we have hence calculate the actual area in square kilometers of this region. So a small thing, they're basically giving you 2 points for going through the hassle of part DI. Let's recall from the context of the exercise that they tell us that 1 unit represents 2.5 kilometers. Así que if 1 unit equals 2.5 kilometers, well, this is our units that we got. So 93.729 units times 2.5, which is the amount of kilometers we're talking about, ¿cierto? Should give us 234.322. Or maybe they actually wanted with, the units like simplified, 235. So I would actually just leave it as 235 and blah, blah, blah. And it's not correct because we have trolled. Why have we trolled? What happened? Give me 1 second to figure that out. Así que, give me 1 second to figure that out. Wow, that is a little harder than what I thought. But let's understand why. I'm glad that happened in the video because it can happen to anyone, and it goes to show that these are hard exercises. See? Now I already know the answer because I looked at it, but intuitively it helps you explain it better. We have that from the context of the exercise. The Voronoi diagram for the 3 fire stations, blah, blah, blah. The grid of the map, we have that 1 unit represents 2.5 kilometers. But because we are talking about units squared, as I said here, you have to have clear that 1 unit equals 2.5 kilometers. And if it's units squared, well, you can think about it as unit equals 2.5 kilometers. So if you were now to square unit, well, you got to square both sides as well. And so 2.5 squared, which is just multiplying it by itself, you have that 6.25. And so that is a small but extremely relevant big brain play that you have to do. So now, so now you take the 94 and you multiply it by the 6.25, and that gives you the 587.5 that we are seeing right over there. Así que, small mistake. They weren't really giving you 2 points. I definitely fell into the trap of thinking that it was easier than what I thought it was. But it goes to show it can happen to anyone. See, and it goes to show that taking care of your units is extremely, extremely important. And if I had a little bit of a sharper and younger mind, I could have realized that, oh yeah, I wrote my answer as unit squared, and they told us that 1 unit is 2.5, which is different than unit squared. And so this little itty bitty step is what gives you that 6.25 right here. Anyways, definitely enough talking by me on this case. That would be for problem number 5 and the entirety of paper 2. I think it's particularly important to point out that for this Voronoi diagram exercise, which does show up once per test, either paper 1 or paper 2, it is so important to understand what is a perpendicular bisector, what is gradient, what is midpoint, what is distance. This is where they test you for all those different things. Notice our formula booklet. The main things they went for was distance, midpoint, and perpendicular bisectors. So they're literally challenging you to understand distance, understand midpoint, understand gradient, understand slopes. It's basically, or I feel like it's replacing a little bit what they used to ask for, like, you have one line, one's parallel to the other, create the third line. This is the same thing, just with extra steps, okay? So that is that. This would be for number 5. Definitely a very complete exercise, definitely challenging. And I hope you added the tool to your toolkit that if you have a crazy image or shape you have to figure out, split it up into many shapes. See? If you split it up into various shapes, it's going to be easier than tackling it all at once. See? I hope it helped. That is number 5, and I'll see you around.